Howdy. How you doing? Welcome, welcome. How you doing, Jojo? Epic. Welcome, welcome. Hello. So yeah, I want to pick up today where I more or less where I left off last time with this. Yeah. So last time we figured out that one. Mostly. Nightmare Joker, how you doing? So we're gonna go and hunt down these ones as well, I think. Maybe. See what the rest of this tape is doing. Yeah, I'm not fucking ready either for Monday. I don't want Monday to come. I don't want to go back to work. I don't want to do it. I don't want to do it. But alas, I must. I must. I need the money. Guy, how you doing? Welcome. Welcome, welcome. I see you peeking there. You know what? Let me, is there a way to... I want to show how many unknowns there are. Is there a way? Can I do that easily without being intrusive? Hunting the assemblies, yes. I don't know about that. It's doing better than on Friday. That's good. The drama's over. That's good anyway, right? I'm not a fan of drama. I'm really not. Parser input script. Okay, gives back a what is that script? Object. Script. There. Tokens, warnings. Tokens? Those aren't instructions, though, are they? Tokens has an instruction. Just you. Yeah, that's just you. Okay, so then, in theory, I can just count how many instructions are unknown. I kind of like a stats file or something like that, you know? Like how many of each instruction are used. For what it's worth, I am now modding 2 of the resulting spin-off servers. Congrats, I guess? Okay, let's have a look at this guy here. Stats file, string. Because I can't really print it out to the console, because that's what that'll do by default. Stats. Help file to write some statistics to. Okay. Where do I get SCR? Right there. Okay. Warnings, sure. Centered error, fine. Do all that. Okay, then here, if args.stats file does not equal that, do stats. Let's instead do that here. Yes. Script. Do write stats. How about that? SCR dot write stats. No. Set file. Yeah, I'll create a file, then pass in like a writer. How about that? Create that. Oops. If error is not nil, return format error f. Right. To create stats file like that. Close. That file. Return format to error f. Error writing stats. Error like that. Okay. Now then, what stats do I want? I would like. So what I would want is the frequency of each instruction, I think, to start. Yeah. And maybe specifically unused instructions, or not unused, undefined instructions. Let's do this. M equals make map of byte and instruction. Yeah. This music seems like really low. Is that just me or no? I don't know. Okay. Instructions. No. Yes? No. I need the tokens as well, because I have to get it out of the tokens here. Okay. For t in range s dot tokens. Something else is variable to inline raw offset. If t dot instruction is nil, continue. Otherwise, oh wait, no, I need I need like a count. That and count int. So this needs to be that. If not okay, if whatever okay equals m t dot instruction dot opcode not okay. Like paste op equals that op. Oh, that's an Archduke. Yeah, well, I won't cut it here. M at op equals stat. No. instruction is going to be that. Count 1. Because we found 1. No, count 0. Because then here, we're just going to do m op dot count plus plus. Yeah. And then for actually, can I want to like sort that I could use this one or no, with slices. So I want to list them out in order, right? So look at slices. No, is it maps actually? Maps. Keys. I don't want an iterable of that. I want a list of them. Okay. That'll work, actually. Okay. I'm motivated on assembly parser. Got a lecture as well. Okay, so it's not necessarily well, it's. I guess it's technically a type of assembly. This isn't this iterable? Yeah. I want to iterate it in a specific order though. Nightmare Joker. Yeah. So this isn't a parser technically for 6502. It's a parser for a domain-specific language that is interpreted in 6502. Yeah, it's a scripting language essentially for these like educational program things on the Famicom. And right now I'm getting a statistics printout, if I can enunciate that word, of the used instructions. Transpile to assembly? Not quite. No. So let me actually bring up the ROM for this one. That's not going to be okay. Up again. ROMs English hearing 6. Okay. I'm gonna go ahead and pause my music real quick. Right there. And I need my controller plugged in. Hang on. Can you not over there? This one. Turn my Bluetooth on. And connect. Okay. All right. So this is the script that I'm investigating is part of this specific ROM. To settings, video size 4x. All right. Pause. Bridgewater, how you doing? Settings, audio, turn on audio. Okay. Can you do that? You can. I have that turned on. Good afternoon. Give it a second here. So right here, the script is running. What the script is doing is drawing and loading up. In a second, we'll see it. Come on. It's drawing and loading up. This scene right here.
Hello. How are you?
So it's a scripting language to facilitate the programs on these cassette tapes. This bastard. This thing right here. So this is the device that these are all run on. And this is all interpreted in 6502 assembly. So if I open up the debugger and look for this one, I think. Go to location. Yeah. So this is the execute opcode portion of the VM in 6502 assembly. So we will be stepping through this in a little bit, because last time we were looking at this opcode right here, 9E. We figured out what that one does for the most part. And this time we'll probably be looking at E7 right there. So like to have a scripting language for mods for these ROMs? Not quite. So it's not like a mod or whatever. It's more of that is the program, right? So all the programs are come on tape, right? I have a lot of stuff open already. So all the programs come on these tapes, and the tapes are loaded into the device, and then it loads the lesson program, whatever the hell, from the tape onto the machine. But it doesn't do it with. It doesn't run. The programs aren't written in pure assembly. They're written in a scripting language that abstracts away a lot of the hard work of the assembly, right? So that makes these tapes easier and cheaper to produce, right? Because if you can get a lot of the common stuff that you need to do in these programs consolidated into a few instructions instead of thousands of instructions, right? You can churn these through a lot faster, right? Like this instruction right here, this unknown 9E. I need to rerun the script so it actually puts the mnemonic there. That like waits for stuff to be read from the tape and then sent to the PPU and into RAM, and then it draws the whole goddamn screen. And it takes seconds to happen, right? But all that is in a single instruction, right? And it expects data to be on the tape in a certain format, right? But from a programmer's perspective, you've got a tool to get stuff into that format, right? So as long as you keep that format, drawing a new screen is one instruction basically, right? Instead of all the instructions to redraw a screen or whatever. So yeah, there's a lot of other instructions on here for like multiplying and some math stuff and looping things and whatnot. But yeah, programs on tape. Yep. Yeah, these are from the early 90s, like 92, give or take. I think that this tape that I have up is from 92 or 93. So, yeah, no worries. Somewhere around there. But yeah, so these are oh. I forgot. I've got all the debugging shit turned on now. So it hit a breakpoint. So here we're about to execute an instruction. Push word to stack, right? What the hell is that? Oh, it's probably like one of these. Honestly, I don't know. There's that's kind of a common one, right? Push word. Yeah, look how many times it's used, all over the place. But yeah. Okay, I'm gonna hit play. I got my music over here. But yeah, so I want to get some statistics a little bit before I move on to the bigger stuff today. So this is gonna be keys equals slices dot sorted maps dot keys m. So I need slices and maps, and then for key range keys m at key, or let's do print line to, oh, that's not a string. Nope. WIO dot writer. And I need to import IO for that. IO. That is what I did. I don't have it open anymore. Cool. command and script decode over here. Yeah, that's fine. W. And for these, func is that string percent 0x no 0x percent 02x space percent s. So that's going to be is.in instr dot string. Nope. That's going to be the second portion of that. Paste that there. Dot op code like that. And I also need a count. Tab decimal. And start count like that. I'm not sure why I'm returning error here, but whatever. Make undefined format, of course. Okay, so now over here, code ness go StudyBox bin script decode segment 00 packet to below 3 script data dat into this that dot text and stats into that dot stat. Okay. A halt call switch. A few unknowns. All right. Where's that 9E? There's that 9E. There's 4 of them in that script. Wow. 112 disable sprite? Jesus Christ. Holy crap, look at this. Yeah, let me reorder that stuff. Put the count there instead of after everything. That's that count. And then unknown is 0. If t dot instruction dot name equals nothing, unknown plus plus, unknown count, unknown. Make. Or what was it? This one. $138. 138 calls to unknowns. Neat. This. 3D? 3, just like that? Will that do it? Will that format the way I want it to format it? Yeah, that works. Hmm. 138 calls to potentially self-modifying code, right? Yeah, a lot of push words and push data. Wow. Pops. Jump 0, jump switch. Or A and B. Okay, these I don't believe are actual calls to these. I think those are all like past the halt argument, right? Past this guy here. Thank you for that follow. Appreciate that. Open read only. So those FFs are like way down here. Now this is all data down here, right? Yeah, you can see. So some of these are actually like referenced directly in this script. But when the script is loaded, it just takes the whole script and puts it into RAM, essentially, right? So by putting something here, putting data here, that is essentially allocating variables, right? Allocating variables with an initial value. Most of these are 0, but a bunch of them are FF, right? Probably something along the lines of like, you know, end of list or something, right? Yeah, and then these, so that means that these would actually be words. What I have highlighted here would be 2 separate variables, 2 bytes each, right? But we go up to way up here, jump absolute, and then these are variables essentially, because that always jumps. Huh. Yeah, there's some audio data there. Play sound, return. Yep, just a return. Oh, because that's probably a destination of a jump, right? Yep, jump 0, return. Got it. Yep. Expansion controller? Like just wait a minute, just expansion controller? That doesn't seem right. It's probably just controller stuff actually, not specifically expansion controller. The engine does some weird stuff with the expansion stuff though. What? Whatever. All right. I want to actually add a an unknown instruction. For just the instructions that are unknown. Make that. Over to here. Quit out of that. 8 unknown instructions. Okay. But they're called a total of 138 times. And this one is probably the majority of that. 108 times. Not probably, it is the majority of that. Because there's only 30 other calls to unknown instructions. I'll give that file, appreciate it. Yeah. 1 to each of these, 1 to that one. Yeah, this is actually the next one I'm going to be looking at anyway. So, because that's the next in the script, I think, right? Yeah, that's the next one in the script. So that's the next one we're going to be looking at. Okay, give it a new line there. Okay, so let's go ahead and reload this. Open this up. Okay. Hey there. I'm just gonna mute the audio for this because I don't need that on anymore. So we're breaking on the first opcode in the script that is going to be running. Once we hit that, there it is. This is so now we know that the script is fully loaded into RAM, so I can set a breakpoint on the script. So that's what we will do. So we're gonna open up this in the memory viewer. No. Code pointer 6004. That's where we want to go. Woo. Oh. Okay. And the instruction we want to break on is E7 at 6002E. This guy. So we're going to edit a breakpoint there on read of that address. We're going to disable a bunch of these other ones. Disable that one, disable that one. 9E. You know, I can actually... wait, 9E. Wasn't that the one we just did? Yeah, draw and show screen. Okay, let's go to this one. Go to location. And on 9E, edit label. Draws a full screen from tape data. This includes loading. Does it actually? I don't know if it does. This includes sprite data. Oh, damn it! I hate that. Jamaica, how you doing? Welcome. Draw and show a full screen. This includes full screen from tape data. This includes sprites. Okay, so I don't need that breakpoint anymore. What is this one? No, 1B. Well, execute up there? No, that's never gonna happen. Actually, wait. Go to. Let's go to that. Those, we don't need those anymore. What is this one? Go there. Yeah, I don't think we need that anymore either. Okay. So now we're gonna break on that instruction. There it is. All right, so. So we are right here. We pushed a bunch of shit to the stack. Thank you for that, Paul. Appreciate it. E7. D. E6, 7. 7 inputs. Oh my god. That's so many. Holy shit. 7 words. That's 14 bytes of input. Jesus. All right, let's see what this does. Oh, sorry, I don't need to do that one. Okay, execute opcode. Jump, handler, E7. All right. Load that. Store that in the high bank. High work RAM bank. And then JSR to the high RAM swap. So we're at 2 and 3 right now. That jumps to... Oh, nope. That one. I need to rename that and this. Because one of these, so this one, this is low RAM, not high RAM. Or no, wait, what? And it with F8. No, that would be... No. It is low RAM because it's getting the current bank right there, anding off the low bank value, and then ORing on the new one. So this isn't high RAM swap. This is low RAM swap. Yeah, that label. High, low RAM swap. And this one, current bank, yeah, this one masks off the high bank. Stores that. Load X. Load A. Shifts that. No, that is the bank ID. That's just the bank input. That's all that is. That's not... Yeah. Specifically switch to the low 3 bits. Yeah, I don't know why 3. Because it only uses 2 of them. Apparently, right? The high 2 and the... I don't know. Okay, so this isn't the high RAM. This no. Work RAM bank. Used when selecting RAM banks. This same variable is used for both high and low work RAM. There. Low 2-bit would be a mask of FC rather than F8. Right. Yeah. The other mask was F3, which is correct for the top 2 bits. Yeah, it isn't 3 bits for the bottom, is it? Did I like miswrite that? StudyBox ls studybox.org. Which one was that again? 4200. Oh, I am wrong. Okay, that is me. That's me. That comment's wrong. Yeah, that was on me. The internet blasphemy. I'm wrong all the time. What the hell you want about? Paste. There we go. Yeah. All right, back up. Work on bank. Okay. Soften that out. Yeah. Okay. Load x0 y branch minus absolute arg a. Huh? What do you mean absolute? Oh, because right, yeah, okay, yeah. Yep, yeah. So it gets the positive version of that, right? So this guy is right there. This one's right there. Let me put a label on that. Edit label. Label 55BD. I'm going to change this label to 55C6 so it's consistent. Yes, that absolute's right there. Swap to RAM bank 0. What? Okay. Store X. Yep. Oh, right. So that X, that needs to be, hang on, edit label. Copy that, delete. Edit. Paste. Okay. So we're at 8F 2 and 3. 8F 0 and 1. Okay. Just start there. What is this one? Oh God. Oh no boy. Oh boy. One of these. One of these. Populates 62, 63 as bytes from table hex 6800. Okay, that table's just written too. Apparently. Table is 6908. Oh, 08 or 80? Because 08 would be up here somewhere, but 80 is this guy right here. That was also written. And label. Index in both is arg a minus 1 times 2. Let's go ahead and get all of our arguments in here. Argument A. Argument underscore A. Argument underscore B. What did I say? 7? A, B, C, D, E, F, G. Oh my God. Argument C. Come on. argument D E F and G. Whew. A through G. What is this in decimal? Unsigned decimal. 65285. Okay, well, about that. X. That's fine. All right. There it is. All right, 1, 2, 3. 1, 2, 3. All right, these are expanded to words before they're pushed, right? Yeah. We got FF, which is this guy here. Then 6F, which is the 111. I wonder why I used it like that. Oh, because 90. Duh. And then this is the result of the negate. Negated 5. That doesn't seem correct for a negate. Because I would expect that to be like, what? FF8 or something like that, right? FFA? I was close. I expect that to be this. Negated. Not FF05. What? That doesn't make any goddamn sense. What is that one? CF. Subtract argument A from 0. Result in argument A. Yeah, what the fuck? This doesn't negate, but don't set the carry. Is it because it didn't set the carry? That's weird as hell. That's fucking weird. Whatever. Whatever. Anyway, I'm gonna load that up. Y equals argument. Okay. Okay. That goes to there. And this is the lookup. Yeah, 980. Yep, that's a type. Okay. Label 980. And this looks to be 16 wide. Table 6800. And this guy. Edit label. Table 6980. Whew. Also 16. All right. Ways to go. How you doing? Yes, this is 6502 assembly. Yep. Thank you for the follow. Appreciate that. Thanks, Josh. Hello. Yes, this is a 6502 assembly for the Famicom or NES. In the back here, this is a domain-specific scripting language that is interpreted in assembly, in the 6502 assembly, and this up here is Go code to try and disassemble that scripting language. So what we're doing right now is we are going through unknown opcodes in the scripting language and trying to figure out what they do. So we can then in turn figure out specifically what the script is doing, right? Specifically. So we're kind of early in the E7 opcode. And this is called 108 times in this script alone. So it's an important one. It's an important one. Yeah. That's also working on FPGA design to simulate 6502. Nice. Nice. Okay, so what is in that table? Get rid of that. I don't need that open anymore. Don't save. Memory viewer. All right, so it's these guys here. We're going to do that. All right. Load that up. Store that into pointer 63. That's probably not being used as a pointer right now. I don't think. $50.51. 1964, put that there. 961, put that there. Okay, pointer 60 looks like it's being used as a pointer. Pointer 60. 5004, okay. Bet you there's another header here. It's probably another header for some stuff. Yeah, probably. Okay. Load that, clear, add 1. Okay, add 1 to that, 5005. X init value is from arg A. But that was just, hang on. A to X. Load A, the low byte of that. Why the, what? So 5. Okay, decrement that. It's not equal, so we're, we're in a loop, yep. Loop that 5 times. Load pointer 60. Clear carry. Add 6. Really? Okay. $501D. Right there. What were the headers in the other one? How big were those? Were those six bytes long? 3 words? I think so, actually. So that's like... Okay, so this is like the number of headers or something like that? Number... Yeah, it's gotta be, right? Number of headers. Skip past that number of headers. Maybe, because now we're at the end of that. So this... Y was... look at Y. Arg minus 1. Load A, put an X, store it there in 66. Decrement. Shift it, load Y. Okay. That index is 1 base. We need it 0 based and doubled. Because it's indexed into words. Word table. Word table indexed from 1. Arg is indexed from... shit. God damn it. X at 0. Arg A is the index based at 1. Based on 1, index at 1. Is the index based on 1. Based on 0. Yeah, okay, there it is. Supposed to put the video about the AI upscale. Yeah, I hate it so much, and that explains what I've been seeing on YouTube, right? Because I knew shit looked off. Shit started to look really off and AI generated. And that just confirms my suspicions, which is cool. In a horrifying way. Yeah, AI upscale in all your videos because fuck you. Yeah. Only on shorts? For now. Yeah, for now. Because they're already doing that AI dubbing bullshit for long forms. God, I hate that so much. I hate the AI dubbing so much. So much. But yeah, the cynic in me with this AI upscaling is like, all right, we'll get everyone just to recognize all videos as like weird AI. Hang on, let me rephrase. The cynic in me is like, okay, people can tell when the videos are AI generated. Let's make them all look AI generated, so then they can't tell the difference. I don't know if it's as overt as that. I don't know if that's what they're thinking, but that's what it feels like, you know? Randomly change your options? Yeah. Problem is, there's a few problems, but yeah. People can't tell. Yeah, that's going to be the thing, is people won't be able to tell between the AI upscaling and an AI generated. And I think that's kind of the point. And I hate that so much. Slash stuff, how you doing? CSI shows and people have been demanding, hey, upscale is great. We can finally take cheap CCTV footage and just scale it to identify the culprit. Letting AI make up the evidence. What can go wrong? All right. What can possibly go wrong? No. Yeah, because that just ruins the trust you have in a creator, you know? Completely ruins the trust. What the hell I know, I guess, right? People already can't tell, but now we who can tell can't teach them what the tells are. Yeah. Yeah, it's getting harder and harder to differentiate because, like, not necessarily because it's getting so good, it's just that the waters are getting muddied, right? It's they're bringing everything down to the shitty level of the AI generated shit, you know? And I hate that. I hate that so much. All right. What do I even want to name this? Like setup header pointer or something like that? Word 96. Wait, what? Word 96 here. That's the start pointer. That's not touched here. It's loaded here, not modified there. That's where that comes from. Okay. Where the hell is this coming from? 4716. That's not one that is directly referenced in the script. 4716. What? Where else is this used? Find all occurrences. Okay, that's clearing it out. All right. No, yeah. That's in our handler. That's that load, and then the next load. And the other store's here. There. Sprite setup. Sprite setup shenanigans. Okay. 16, where was it again? Over here. Was it in here? Where the hell is? Oh, right there. 96, but it's out of the pointer shenanigans. And this, add a pointer to the data it points to, so there's depending on the okay, so that's the output of word 96 is the output of a bunch of this stuff, right? Story there. 96 is another output as well. And label. Okay. Yes, that's like some Sprite stuff, I think. Is there any, No. It's already hard to tell texts that were generated by LLMs from genuine text. Yeah. Yeah, and with that, it's there's no like cut and dry like, oh, this one's AI, you know. It's more of, oh, this one has a higher frequency of using these phrases. The chance of this being AI is very high. Right? We're on the worst timeline. All right, word 96, we're going to add this to here. Word 96. 5004. All right, yeah, so that's the... So this must be getting the end of the header. Because 96 points to the start of the header. And pointer 60 is the end of the header. Yeah. False positives are massive? Oh, absolutely. Yeah. The best tell nowadays are mannerisms, using EM dashes, building pairs of 3 in a sentence and so on. Yeah. Yep. One good thing about it, shoving it down everyone's throat just makes people hate it even more. That's the hope anyway. But. All right, so we're gonna load that up. Right there. Branch equal. It's not equal. Compare that to 5. To 5? Plus. Oh, if we're done, compared to done. That's a loop. No. What? Where was that? No, that's not a loop. Why would it be just comparing it there then? Okay, it's an out of bounds check at the top. Pointer 60. Wait a minute. Are these like 2 headers? Word 66. Load argument G. As a byte, yep. G being the last one. You know, I need a list of like a readable list that isn't in source code of all these opcodes and like the arguments and like what they do and all that kind of shit, you know, what they're for maybe, and the size of them, because apparently, well, even though they're all words on the stack and in the arguments, as you can see here, sometimes they're treated as bytes. Stack inspect. Someone jumps over the harder stack. For 256 bytes, look at that offset. If the value equals arg A, write value to offset from 48. What the fuck? That's extra arguments. How many extra arguments there are? No. Oh, Jesus Christ. Is that what that is? Not sure how far I am. I just unlocked the shirt one, I think. I don't think I've started it yet. I haven't started it yet, though. So, I have not been moving it nearly as fast as you have been moving. All right. Yeah, you know what? Let me do this. So I've already got docs, nothing in there. Okay. Instructions empty. Okay. 0xe7. Arg A. What is Arg A? That's the top one up here. So this guy here. That's going to be a count of something. Arg B. Haven't seen it yet. Arg C. Same, right? Yes, we've only seen A and G so far. This guy doesn't touch any... It touches Arg A, but none of the other Args. This one is just swapping RAM banks. Extra args on hardware stack. Oh. Argument 7. No, apparently plus whatever the hardware stack does. Yeah, so I don't know exactly if that's... I don't know if that's extra arguments or just like... Or just like, okay, we've got extra data. or we have this set of data that we also need to handle. Like, so I don't know if that's like hey, we have none of this type of data, or one of this type of data, or two of this type of data, which is expected to be in a certain spot on the hardware stack, right? So I don't know if that's actually like stack variables or whatever. I don't know if those are if that data is treated as variables or data, if that makes any sense, right? As arguments or data. So that's the question for now. Now, all right. Load that in A, load Y. Compare that to what the fuck? F? Wait. Stack inspect also looks at 140. What the fuck? For 256 bytes, look at that plus offset. What the fuck's the offset? If value equals arg A, write the same value. Y 0. (4B), that's all FF. Well, no, that's... If it equals 5, right? Okay, yeah, it's not like if 0. No. It's if it equals 5. These are like IDs of some sort, right? So loading up argument A again. What the fuck? Why? That's not equal. So none of these are gonna trigger. What's that for 256 bytes? Looking for a 5 in here. It's a 3. It's close. 0, 4C, 7. Another 7. 2s are close. Okay, so there's no other 5s in here. And that'll go down to 240. That's so fucking bizarre. Branch not equal. Yeah, for 256 bytes. Because then it looks at that table again. Looks for that same value. Load X. Compare X. This loop makes no goddamn sense. So this will only happen if arg A is FF. But that's at the end of it. So that just skips this. Whatever the hell this is. Y is 0. Okay, we're going to increment that. Look for 40? What's that, 32? No, 64. this some sprite bullshit? Compare Y, not equal. Is this wait, is this finding a sprite? Like looking for a sprite ID or something? $16. 32. This is 48. I think, right? Because none of these are going to hit it. Divide coding. Ew. Ew. I hate that. 3F, press not equal. Okay, and then the last one. Whoa, whoa, where did we just come from? What was that? JSR over to here. Okay, so we're outside of the loop. Ew. Yeah, vibe coding. Yeah, that's the whole, like, you know, just letting some generative AI code for you. Prompt engineering bullshit. Fuck off with that. No, stop it. No, vape on screen 90% of the time as well, right? Okay, what the fuck is this doing now? Pointer 60. We were looking at that before. That's the start of some data, right? If you need data to do your job, you should be doing your job. Okay, so we're gonna have a look at this again. View. $51F 19. Okay. I forget what these two are being used for. Those two fives. I forget what that was being used for. But we're looking after that now. So is this like a secondary header or something like that? 19. Store that inward 68 plus 0. Increment Y. 0, 0. Store that 68 plus 1. Okay. Thank you for that file. Appreciate it. 19. Okay. Load that. Compare it. Branch equal. Okay. Load that. Compare it to 41? Sprite count. If it's branch carry clear. If it's less than 41, we're good. This is out of bounds check. If no, cancel. If word 68 is greater than 40, load Y, FF, RTS. Six four two goes is an interesting combination. John Steph, how you doing? Do you write tooling around 6502 assembly in Go? Yes. The tooling around it is in Go. Yes. My assembler is not mine really. I'm using someone else's assembler. the assembler is CA65 of the CC65 suite. I am writing some disassembly stuff in Go, but it's not 6502 that I'm disassembling. It's a script. It's a domain-specific scripting language, or domain-specific script that I'm disassembling in Go. And this script is normally interpreted in 6502 assembly. So that's what I'm stepping through here, is the 6502. And back here, like over here, is some of the Go code to disassemble it, right? These are some notes. And this right here is the disassembly of the script I'm currently looking at. So right now, we are looking through that instruction, E7, that unknown. And it's got 7 arguments. So one is, the first argument is the negation of 5, which is somehow FF05, which doesn't make any goddamn sense to me. And then these are all just static arguments. Also, wait a minute. Why the fuck wouldn't you just put the actual value you wanted on there instead of an... Oh my god, that's a hard-coded 5, and then, hey, we put 5 in the stack, negate it. Why don't you just put the actual value you wanted on the stack? Oh my god! Yeah, FF05. Exactly, because when it does the negation, when it does the subtraction, it doesn't set carry. So it doesn't become FA like you would expect. Is it raining outside? Is that what that noise is? I'm gonna check real quick. Hang on. It is raining. I can hear the rain falling on my air conditioner in the other room. That's why I'm like, what is that noise? Because it's hitting the metal on the top of it, right? Yeah. Now I want to know which idiot wrote the negation code. But if it was written correctly, this wouldn't work. Because that 5, that 0, 5, that 5 right there is used as 5. The upper byte of that isn't used. What? So this negate shouldn't even be there so far. As far as I'm aware, that the upper byte of that operation isn't even used. And we're not fully through the routine yet, but yeah. I suspect this routine, by the way, is something for sprites. That's what I suspect. Like a sprite animation thing or something, you know? Because there is a lot of animation in this thing. In this script. In this scene. Whatever. I want to write even more. Yeah. Do you honestly think whoever works on these study games really loves their job and is actually good at it? It can be a mix of things, you know? So, like, where at my job, right? There's some stuff that I do enjoy doing, but there's a lot of shit I do not enjoy doing at my job, right? And a lot of things that, like, someone else asked me to do that I just, like, throw some bullshit together and get it done, right? And as per usual, the things that you spend time on to harden, right? Like, make it feature complete and, like, rock solid, right? You put a lot of planning into it, right? That thing, barely ever fucking used, right? But the little script that you just needed to, like, get into place to make something more sane, right? But it was I'll fix this later. It's a temporary thing. I'll come back to this. And you never do. And that disgusting code is in production long after you leave the company. Right? What would happen? I don't know. I'd get some marshmallows and roast them on the fire. Honestly, considering how some of that stuff works, at least some people involved in the project and the creation of the StudyBox surely was passionate about their work. Oh yeah, yeah. Some of this shit in here is fascinating. Yeah, really clever shit. And I mean, the design of the thing in general is fucking clever, right? So like around this time, right? For tape storage of programs, it was like compile. It's a binary, like of like, you know, for the Commodore, it would load off assembly, right? But this, they're like, no, let's make it easier on ourselves, and create the scripting language so it's easier to write these things and churn them out, right? Nothing is as permanent as a temporary fix, right? Kinslay, how you doing? Kinslayer. Hello, welcome. How you doing? Thank you for the raid, appreciate it. Clever stuff they bought and turned into this, most likely. I don't know about that. I don't know. It's possible, sure. But then again, the company that made this thing originally was bought like a half a dozen times. I don't know. Since the 90s when this was made. I mean, they're still like a language company, but they're not doing this anymore, I don't think. Having an interpreter running on the NES for a completely different bytecode is an astonishing feat. Yeah. Oh, yeah. Yeah. It is fascinating. And yeah, I mean, like, they have, like, multiplication routines in here that actually, like, are fairly efficient, right? As efficient as you can be on this hardware, right? Without having some sort of like, you know, hardware multiplier like the MMC5, which this predates the MMC5, doesn't it? When was that released? MMC5. Manufacturing started at the end of '89. Okay. But the development of the StudyBox, I believe, predates that. Tiz 100 is a fantastic game. I need to get back to that one. I got to a certain puzzle in that game. It's one with the graph, right? Where you're given data and you need to make a vertical bar graph, right? And I coded it all up and got it finally working. I hit go. And the bar graph is rotated 90 degrees. So then I'm like, all right, I'll take a break and come back to this later. That was like 10 years ago, I think. I don't know how long ago. I need to get back to that one because Tiz 100 is a fantastic game. Some of the earlier versions of BASIC were essentially bytecode too. Yeah. Every command was a byte, and even key on the keyboard like that too. Yeah. You buy it. Tiz 100 is worth the money. It really is. I think people don't realize how common this kind of thing was in the 70s and 80s when you didn't have a lot of options to write languages. Easy ways to communicate with others. Everything was proprietary. For example, Chip 8 was a VM for the 70s. You had the Z machine, lots of similar systems. Many lost the time. Yeah, that's true, I suppose. Never mess with assembly, so you're struggling. So the Tiz 100 assembly is... that isn't real assembly, number one. It is a puzzle language, right? Any real assembly has significantly more features than what Tiz 100 has. So I'm knee deep in 6502 assembly all the time, right? To the point where like the actual assembly of 6502 isn't the hard part. It's like these are like looking at tables and shit. So I'm right now I'm trying to figure out why the code is looking at these different tables and, you know, what it's trying to figure out and all that kind of shit, right? It's not necessarily the assembly of like, oh, what does this instruction mean, right? Tiz 100 though, and Shenzhen IO is another one. where you're so confined in those environments, not just the language, but like, so with TIS 100 and Shenzhen, you can't have pages and pages and pages of assembly. In TIS 100, you have this little, like, what is it, like 7 lines per block or whatever, right? Shenzhen is a little different. It's got the different circuits that you can like place in some of our different sizes or whatever. But still, it's a restriction, right? And getting stuff working in those restraints is a challenge. It's a big challenge. But not everything that you go over in TIS 100 and Shenzhen and the others. Not all that stuff truly translates directly or really even that well to other languages. Like with TIS 100, it's very multi-threading is not the right word. Well, maybe it is. I don't know, because each of those cells like is its own thread, as it were, right? Because they each execute instructions on their own. Exapunks is also fantastic. It's another one I need to finish. I've got a new job. Once I get a new job, yeah. The Zachtronics games are fantastic. They really are. And his new company. Coincidence? Right here. I am following this company. What the hell is this? What the fuck is this? Math game about racing. Okay, never mind. Racing game about math. I don't know about that. I'm not doing that one. I'm not doing that one. Nope. Anyway. All right, next. Okay, so flag 80. What the fuck is this? Set the hex 40 after clearing some RAM. Ha ha ha! Okay, this is sprite related, probably. Free sprites? Number of sprites available? Load that, set that. Subtract 19. Is that how many sprites we're setting up? This is what the screen looks like right now, by the way. Sprite viewer. Nothing is set up right yet. What is hex 19 in decimal? 25. Okay. Multi-process, yeah. For Shenzhen, aren't some of the in-game manuals in different? Yeah, in Chinese. That's the thing. It's Shenzhen with a SH, not CH. Because the whole like story of that game is you move to Shenzhen, China, and you're building these electronic devices to sell, right? Yeah, you're building these circuits with random ass chips. And the chips have their own, like, user manual, spec sheet thing. I don't know why I wasn't Kaizen fully in Japanese. Because there's no manual for it, right? There's no manual for the parts. But yeah, so most of the documentation for Shenzhen is in English, but there's a few of them where the documentation is only in Mandarin. I think it's Mandarin anyway. It might be fuck, what's the other one? The other Cantonese. It might be in Cantonese. I don't know. So it's in one. It's in a Chinese dialect. It's a Chinese language. Yeah. But there is no like official English translation of it. It's just like, here you go, good luck. And the and like, if you were to translate it, it's basically like you machine translate it and it reads like a poorly translated instruction manual that you would get from AliExpress, right? For something. So it's like barely helpful, you know? And then there's that one chip that's got the sanded off face on it, so you don't know what the fuck it does. All right. Carrie's set. Carrie is set. What is this? Label 5758. I get the fun about the games, but if I want bad manuals, I go into Internet of Things. That's basically an Internet of Things game, right? Where you're making these little things that are in the real world anyway, like an Internet of Thing device, you know, like controllers for a camera. Or actually, one of them was the camera one was like a fake camera. So you just need to make a controller that will blink the LED in a specific pattern, right? Like that's all that's in it is a circuit board for the LED and power and like a lens that looks convincing, right? No actual camera inside of it. Okay, so these won't happen. But what are these? Look at that table 140 again. Aha! It is sprite shit. Okay. So this is checking for if we don't have enough sprites, some sort of sprite cycling thing. Yeah. Maybe. All right, let's put a label on these. Add a label. Label 577A. It's an RTS. At label 575B. That's a loop. Transfer A to Y. Okay, so we're subtract that. Okay, so we have 19 sprites that we want to add out of available, or heck, there's 25 sprites out of an available 64. If we do not have, if we do not have enough available, this right here disables a bunch, doesn't it? And this, for one, jumps back up to the top. Okay. Interesting. Why wouldn't it... Why does it jump back up to the top there? Because this should take care of all of them, shouldn't it? Flag 80 isn't touched here. Wait. Flag 80 is touched. Table 140 value. Table 140 has to be sprites. Yeah. This kind of translation. What is this? So this what, like disables one sprite? Wait, this is looking at argument A. What the fuck? This is fine. Transfer A to Y. Load A, FF, transfer to Y, increment. Okay, so we're starting at 0. Go right to 40. Branch equal done. Start at the top of it. Okay. Compare that to FF, branch equal to the loop. FF. It's not. Load. Store in the top. Whoa. Okay, now we're touching the top byte, but what? That swaps them. What the shit? Yeah, so that saves it. That's for A to X. Saves whatever that value was, puts it in X, and then puts that in the... Wow. All right, Gamba, yeah, have a good night. Thanks for stopping by. I appreciate it. Hope to see you next time. Because this disable sprite... Well, that doesn't touch... no, that does touch RGA. All right. Because that's an opcode. Wait, no. Hold up. This one. That just disables the sprite. Okay. Wait. I confused myself. Oh, each loop of that disabled waits a frame, doesn't it? Oh, that's disgusting. Whoa. So that call waits at least one frame. Oh, boy. Burns at least one frame. Yep. All right. So we don't need to do that. Store A in flag 40, 27. That's now the number available. Yeah. Available sprites. Load YFF, load X0, increment Y starting at 0, all right. Load A, compare to FF. Branch not equal to the loop. Okay, so we're finding the first available sprite. Yeah. Load argument A, 5. Store that in table sprites. Compare X to 0. Branch not equal. Store Y. Four, 5, 7, 2. For X, compare X to 19. We're not done yet. Okay, so this table here is like a sprite reference table, basically. Yeah. and setting all of them to 5. So 5 has got to be some sort of like meta sprite ID, maybe? No. Where do we get word 68? Where did that come from? Pointer 60. From the data, okay. Oh, we got the IRQ. Oh, God, I don't care about that. Yep, and we're gonna put a breakpoint right there. Store Y, load Y. Okay, so that's just saving that. That only ever stores 0. Whatever. Why? Huh. No idea. No idea. All right, RTS that. We're going to have a look at the memory viewer again. Let's have a look at the RAM for that now. Yeah, so we've got 5 in here. 25 bytes of that. That was this. So this is something to do with sprites. Allocate sprites? Allocate sprites? Writes a value to the table at 0140 arg a times arg a low. Yeah. All right, compare Y. It's not FF. Not equal, 610. Where is that? Oh, that's RTS. So that's if there's none left. What the fuck is this then? Edit label. L5671. All right, what's in here? Argument E and F are used. Okay. B and C. Okay, so here's the rest of the goddamn arguments. B, C. Well, no, where's D? Argument D isn't used. What? F. E and F are 0. Okay, load X. 0, load A, argument E, branch equal x20. The progress I stole, yeah. All right, store x there, sure. So E is just 0 or hex 20 for whatever the fuck this is. Okay. Okay, that. Clear carry, rotate. And it with C0. The fuck? Or it on to 89. Oh. What? So that's the top two. Take the bottom 2 bits of this and put it on top of 89. By 89 equals arg f by 3? Yeah, by 3. And it with C0. Or it with byte 89. Zebus, how you doing? Zebus Naga, do you remember what you had to change in XFC to allow a volume track to show multiple outputs? I didn't change anything. This one here? I didn't change anything. Oh. All right, so take. Whoa. So that is the middle 2 bits of that. Those are put on top of either hex 20 or 0. Arg F and yeah, that's going to be 18 is put R is placed in the top 2 bits of either 0 or 20, depending on the value of arg E. Okay, sure. Still zeros though. Fine. Load F. Okay, clear out some stuff. No, clear out 68 plus 0. Wait a minute. Hold up. Load A store. Wait a minute. Wait. Back. Load AFF. Store it. 68, 66. Oh my god. Load A5. Store that into 6B. Load 66 plus 1. 6D. Okay. No. That's fucking weird. What the fuck? I don't know what the hell's going on there. Your show built an output, mine does not. Super strange. Ah. Do you have something plugged in there? What is it under? Not system, right? No, it's like audio or some shit. Where's the media? Volume control. Ignore the combined. That I need to get rid of that somehow. I forget how to get rid of that. I don't know. All right, so 66 is split across two other variables, but weirdly, excuse me. Okay, argument B, load that up, put it in byte 6A, argument C in 6B. Okay, so argument B and C are bytes. And so is this one here. This one's read as a byte, but both are used. Mike Corey? Am I saying that right? How you doing? Welcome. E is some sort of switch. Byte. Switch of some sort. Makes sets X to 0, 0, or 20. So it's X to 20. No, 0 if 0. 20 otherwise. If not 0. Yeah. Okay. All right, load the table at Y. Where do we get Y from? Y was from outside of this routine. It is the current... What the fuck? Wait a minute, what? Increment Y, compare Y to 40. Y is 0 right now. Because that's at the current spot. We are in the... Right, because the loop before this... this loop right here finds the first available spot. That's what that does. Okay. So we are at the next available spot. Okay, so Y is already set. Yeah. So it's crazy to think about. It's not that bad. Confusing as all hell, sure, but you know. All right, compare that to A, the length of it. No, not even like the value. Branch equal. What the fuck? AB, way down here. Right, scroll. What the oh, what the shit? Oh god, that burns a frame. Word 4571. 2 bytes. All right, load word 66. Set carry, subtract. D0 or 60 0. Yeah, store that there. Load 5 minus 5. Okay. Shifted a bunch. Clear carry. Add 6F. Where the fuck did 6F come from again? 6F is argument C. Right there. Maybe. So these arguments coming into this? And this, subtract, wait, what the fuck? 6b plus 1 from word 66. What the fuck was that? From the pointer. Oh, God. Pointer 60. Okay, 6B. Still in 6B. Okay. Load up that. Set the carry. Subtract 6B plus 1. Plus 1. Where was that one? It's also from that pointer. This is the emulator Messin. So it's paused right now. Don't worry about the colors. It's in the middle of drawing some shit. But this is a NES emulator, NES, Famicom, and a bunch of others. Tools. Yeah, it's the second link there. Fantastic emulator. It's got some amazing debugging tools. So this right here is just the debugger, but it's also got, like, you know, a sprite viewer. It's got a memory viewer, which is all this. It's got a tile map viewer, showing all the tiles and the colors they're supposed to be. A tile viewer. All kinds of stuff. Event viewer, right here. The yellow line there is where the beam currently is on the virtual beam on the screen, right? So this is paused mid-screen. So if we pause time on a real TV, this is where Though that dot, actually I don't even know. I think it's this dot. Is this that dot? That dot might be where, exactly where the beam is. I forget. But this shows all kinds of like events that happen during the frame. Register viewer, trace logger, some memory stuff. But yeah. Yeah. It's a fantastic emulator. All right, so track that, store that there. Some shifting. It's 5 and 5 though. Like what? I don't understand. Clear carry. Add byte 6A. What the? Where was that from? That was from argument B. Okay. Argument B. Store that. And oh Jesus, what is this? Where are we going? Label 56F8. All right, what's in here now? Oh god. Okay, so we're backing some stuff up. I'm backing up Y. Transfer Y to A. Push A. Transfer Y to A. Transfer A to X. You didn't need that second transfer Y to A because it's already in A. Whatever. Probably macros. Right? Back up Y. Transfer Y to X. That's probably two separate macros right there, right? Or this could actually be a macro right here. Right? For shifting Y. So yeah, multiply by 2, multiply by 4. Right? Yeah. Put that there. Oh, yep, sprite shit. Oh my god. All right, Y0. Put that in A. Just Y to A. Put that in X. Shift it. Put it back in A. Yep. Load word 6B. Oh, that is a value. Okay. 6F. So that's argument C. We're storing that. That's a Y coordinate. Increment Y. Transfer Y to A. Push it. Really? Oh, no. There's argument F. Label 57C4. Before we go any further, this here sets up some sprites. Yep. All right. Argument F. Load that. Branch not equal. Increment word 68. 68. That was... 68 right there. Okay. RTS. That just changed the location of that. Because that was the last one. Otherwise... Ooh, okay. This is coordinate math. Okay. This guy, what that is. What is 6F? Oh, there's 6F right there. So this is Johnny coming in from the side. So in this scene, Johnny walks in from the right hand side into frame, right? So that's part of Johnny's meta sprite right there. All right. Load argument A, set carry, subtract 1, ASL, put that in Y, table 68. Okay, so this is going to be, like, maybe either attribute or tile? What is, which is which? I keep forgetting. Tile. Okay, so this is probably the tile. Table of tile data. No. Memory goer. Y is 8. 50. No. F1. Okay, what is tile F1 right now? Nope. Five or static, one of the two. Is that just because it's not loaded yet or something? Is that what that is? Store that in word 56. 50 in word 56 plus 1. Okay. Word 68. What was word 68 again? I don't remember. Started as FF, okay. Word 56. Oh god, where did that come from? Oh, that's literally right here. That's a tape. That's a pointer. Oh god, that's dereferencing a goddamn pointer. Oh no. 50 F1. $48. Put that in X, Y, pull A, okay. Put that in Y, transfer X to A, 48. Store that. There, 48. Okay. Where did I put that in X? Pull A, put that in Y. Where was A pushed? Transfer Y to A. Push A. Increment Y. Okay. Right there. This is the value that we grabbed just now. From there. Load argument D. Oh, God. Now there's D. Okay. Branch minus. This is also a byte. Apparently. Branch plus. That's the end. Okay. All right, label 5748. Branch minus. Argument demodified? Just for Y to A. Push it. So saving the index we're at. Load up argument A at 5. Set carry subtract 1. ASL. 8. Again, that's the lookup into that table. So, okay, so this is a table lookup. Yeah. Sprite data at 6980. Well, okay, well, 6980 is the pointer to sprite table. Kind of. Look into a meta sprite pointer table at 6980. Okay. Hold 1. Put that in X. Pull A. 2. Put that in Y. That. X to A. And it with 3. Palette. Palette. I have to sneeze, hang on. Okay, we're good. All right, let me go over here real quick. View main reviewer. Tile. 25 bytes. 25 bytes. These are the tiles. Those are the attributes. These are frames of animation, aren't they? For each meta sprite, because that 48 I see again. 25 bytes. 25 bytes changes to 52. Or 25 bytes, right? Right up to there. 30 bytes. No. 25 is there. Maybe one of those fives that I saw in that data somewhere. So one of them. So there's 2 05s in that original data. The header data somewhere. 60. Whoa, what the fuck was that? Not any one of these. So these are pointer tables. 510A. These right here. So I bet you one of them is like an ID, and then the number of frames for that, like animation or something, right? And this is the number of tiles for that Metasprite. Maybe. Increment, load byte that. 6A. 6A is X. 6A, where did that come from? No, shit, where was I? 6A, argb. Argb is X. And this one's probably Y chord, right? So this is probably like setup Metasprite. Sprite ID. Pull A, put that in Y, RTS. Haha! That is loading up a single sprite. Look at that. That is Johnny. That's Johnny right there. Okay. Okay, load single meta sprite tile. Okay. Decrement 6b plus 1. Branch not equal. Y. Robert had 5 fingers. Is that its name? Okay. Now let's see what the next sprite is. I'm just going to jump over this. Yep. Okay. Decrement branch not equal. So this is a loop. Well, no, that's loop next. And this 9.3 is loop top. Loop next, loop next. Where's this one? F7? Oh, yeah, loop S there. Loop top. Nope. Nope, 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 not that one. Loop exit. Wait, what the fuck? Why the oh my god. No, that's not exit. That's jumping over the RTS. Why the shit would you do that? Why not just have this branch not equal to the top of the loop? Why? You branch to a jump to the top of the loop. What the fuck is this? I hate that so much. I hate that so much. That's so stupid. I bet you it's some more macro bullshit, too. That's probably what that is. God, I hate that. All right. Right there. That's one row of it. 1, 2, 3, 4, 5. That's not count. That's width and height, isn't it? So this 5 is like a sprite ID or meta sprite ID, and the 5s in the data are a width and height. That's exactly what it is. Any Magic Knight? How you doing? Is the branch more than 128 away? No. This branch skips a single byte. This jump goes right there. Not even 20 bytes away. 15 maybe? It's literally right here. It jumps to right there. It doesn't make any goddamn sense. It makes no fucking sense. Oh. But that's par for the course for this damn thing, all right? It's par for the course here. All right, 3. Another 2, 1. Okay. And that this is more than one meta sprite, isn't it? Where are we in the frame, by the way? Because we were at the top of the frame earlier, close to the top of the frame. All right, yeah, we were like up here before. But this much time? Like a full quarter of the frame for one meta sprite? Oh my god, that's disgusting. A+1 FF branch minus, so that's oh no. That's RTS. This here is setting up for like writing that shit to the PPU. So if I go over to, so I'm looking at CPU memory here. If I go over to sprite RAM, it's not there yet. RTS. Restore previous bank, sure. RTS. That was an opcode. That is load Metasprite. That's what that is. Yeah. 7 negate. That 7 is the Metasprite ID. A, B, what was B again? X coordinate. Okay, then the Y coordinate. Pushes that. And adds 8? That's a weird off by 1, too. Okay. Yeah, so it takes... Oh. There's Y coordinate. Yep. Push word FF. What was it? D? Still don't know what the hell D is. Was that used? I don't remember that being used. And then 3 zeros. A switch, extra hardware stuff, and F was... Oh, God. F was used somewhere, wasn't it? What was that used for? It was the same area as arg E, wasn't it? Oh, we're still in the same frame, by the way. We're down a little bit further. F. Byte 89. What the fuck was byte 89 used for again? Oh, Jesus. That's this one here. 87. Palette data. Palette offset? Because it has the palette data in there. Palette ID offset. Okay. But F is used. C0. So that offset though is that. What? Because it only uses the two center bits of that, doesn't it? All right. Anyway, what was argd again? Where are we? Did we ever? Was argd actually used? B C A F E A D. Some coordinate shit. This one's getting palette data. This is getting attribute data? Attribute data, maybe? Breakpoint there. All right. Yeah, so it's not set up yet. That's fine. Okay. It has the Y coordinate set, but not the X coordinate or anything else. All right, load that 7th shore. We're gonna look it up. Put that 56. Put that in X. Pull A, put it in Y. X back into A. Y is 79. Yeah, it's attribute data. All the attribute data. No, that's... Wait. No, that's tile data. Never mind. That's tile data. Right. Okay. Tile data right there. Oh, yeah, tile data. Label. Set tile. And pal chord. Y, load that. Branch minus. Otherwise, if it's not FF, okay, so that would go down to here. It would skip loading that. So it's like an overwrite of palette data, I guess. Kind of? Palette override. That's all that is. Just palette. Palette override. Well, then what the fuck is this then? Hang on. If positive used if positive bottom 2 bits are used directly for palette value, palette index. Yeah. I don't know if that one's a byte, really. Ugh. RGAF. What are the middle two bits of that actually? Unimplemented. But that would be the flip. No, not ID offset. No, this is sprite flip. right? Yeah. And then arg G, that'd be like a backup. Like load from backup or something like that, right? Not extra arguments, but the table we're looking at is somewhere else. I think, right? What handle are we on? E something? E7 or something like that, right? This guy, location. No, that's a backup, right? Copies the sprite table. Sprite enable table to work RAM. That's what that is. So there's a few of them there. There's only two of them, really, actually. Where was that? Header 5, 5, 5, and 6. 6 across? No. What the fuck is this? Oh. One, two, three, four, 5. 1, 2, 3, 4, 5, 6. That's height. That was the height of it, wasn't it? With height. 1 is the number of tiles. Okay. Width, height, count. What the hell was the zeros? Unknown. Maybe that's... No. That wouldn't be, like, bank or whatever, because that doesn't make any sense in this context. So I don't know what those were when it was being read. Yeah. Palette? Maybe. Palette? Yeah. And then locations for this stuff is somewhere else. Edifaus, how you doing? Welcome. $60. So 30 each. Yeah, okay. So looks like there's 2 frames for the top. And probably another 2 frames for the bottom, right? So that's 60. Another 60 is... to there, though. That doesn't look right. Brit QK, hello. How you doing? Welcome. Doing okay. What are you in the middle of? I'm in the middle of code that figures out meta sprites. So, opcode E7 loads a meta sprite and loads it up into RAM. I think at the end of loading, it also triggers it to draw, right? This bullshit down here, I think. No, here. Argument A. Possibly? Is that might actually fully set up yet? Okay, so that one wasn't fully set up when I saw it last. Next, load that. RTS it. Show the previous bank. Okay. The next opcode. Tape NMI setup. Okay, so it's loaded into RAM, but... Oh, it was. The timing of that, though. That was at the very bottom here, I think. Simply, hey, doing? I think this older CPU are not much prone to Spectre. Not much prone? Spectre doesn't exist on this kind of stuff. Transfer it in there from somewhere. Yeah, well, so I think it's just a timing thing. So you know how like we'll see sprites that are like half off screen or whatever? That's all a timing issue, I think, with this specific code. Your Theo's old. Oh, okay. Welcome. Yeah, that's jank as hell, though. You failed. Oh, no. It was good going there. That's good. At least you had fun, right? So sometimes the code sometimes is too slow and the NMI hits too soon. So So it's just oh yeah. So we started loading this Metasprite way the fuck up here, and it took the entire goddamn frame to load. This is actually 2 separate Metasprites. So it's like about half a frame to load a single Metasprite, depending on the size of it, obviously, right? But this guy, so the first Metasprite, so they're both 5 across. The first one was 5 high, the other one was it 6 high? But it took the entire goddamn frame to do that. Did a Tetris relay with Father Tappers? Oh. SV and Dan and I did a relay with the eventual winner that beat my qual score. Oh. Sounds like fun. Also, nothing you could run on it that would even be a security issue? Yeah. No. I compare that virtual register issue, just pure assembly and force branch to run malicious code. So getting this to run unintended code is hilariously easy. So back before we started reverse engineering the engine, when we were just trying to figure out like the bare minimum to get this stuff emulated, Bridgewater was able to find an ACE exploit, right? That like hammered the stack and changed the return code of something, right? And then while we're like reverse engineering the script, there's just an opcode that's just like, hey, jump to this assembly address. And it's like, oh, fuck. We didn't even need an exploit. It's built in. Which one was that? Jump to the inline word in the VM. Colors in the word in the VM. Jump to the inline address in assembly, not in the VM. Like, what? Fucking what? That's just an opcode. Right? So, A7. Let's have a look at the code implementing that real quick. Go to location. Load that, store an argument, load that, store an argument. Swap RAM. Fucking jump. Just jump there. Just what? 6 bytes? Yeah, it was like 5 or 6 bytes. Something like that, yeah. This is 3 bytes. 2 for the address and 1 for the opcode. Well, okay, actually it's probably more than 3. 4 bytes. So 3 bytes for pushing an inline word to the stack, to the VM stack for the argument, and then 1 byte for the opcode of this call assembly. Potentially useful, allows you to return into the VM easily if you want to do it for whatever reason. Yeah. Yeah. So this right here seems like built-in facilities for like optimized code for something, right? Like if the VM is too slow for this certain thing that you need to do, you just have that blob in the script somewhere, right? As like, you know, at the bottom of the script or whatever. And you just call this in your script. So you can run an assembly routine from tape if you wanted to. And then RTS out of it, right? So it'll come back here and then continue in the VM. Yeah. Anyway. So. What was that? E7, right? Yeah, E7. Draw meta sprite. Now, all right, I need to hit the bathroom real quick. I'll be right back. Don't go anywhere. Be on top. Hello. All right. So yeah, we're gonna call this one draw meta sprite. Okay. So now make. Rerun that. That's not what I wanted. Over here. E. Ta-da! Draw meta sprite. Fantastic. Unknown instructions 7. Unknown count 30. Took 108 calls off the unknown. Yeah, this negate. Something tells me that's not really negate anymore. All right, what's the next unknown? My trust assembly. Ooh. A9. Okay. Let's see. Let's have a quick look at A9. Before that, actually, let me make sure I've labeled E7. I have not. No, cancel. Go to location. Draw. That is sprite. I do actually want all of this stuff in there. Okay, so arg A sprite ID, arg B X coordinate, arg C Y coordinate. NSCFI2 simply works how it works. I understand it for the Commodore, but I might try NES programming. NES is fun. I enjoy it. I haven't done Commodore stuff. The main differences you'll hit are, the graphics and the audio stuff, because those are obviously different on the two. But the actual assembly underneath it is the same, minus the decimal mode. Yeah, the NES just doesn't have decimal mode, whereas the Commodore does. So you can't do like packed decimal in bytes. You gotta do that shit manually if you want to use it. RD palette override. RE some switch. Don't know what that's all about though. RE arg F sprite flip. Remember, it was probably different. Yeah. I mean, yeah. So the first 2 pages, 0 page and stack, are going to be the same. Only because that's a hardware thing with the 6502, but everything else is different, right? Everything else. Well, then also the what's it? The interrupts at the very end of the address space. Yeah. So for the NES, the hardware registers are mapped in like the 2000 range and the 4000 range, whereas I think for the Commodore they're way up at the top, right? They're like in the last page or something like that. I don't know. Check the vibe coding stream quickly. Saw the name of the project: AI Slop Survivors. So actually, what was this? It's just like, swap sprite table. I don't know. Commodore 64 assembly quirk is that addresses 00 and 01 can't be used to store stuff properly because the Commodore 64 runs on a 6510 and those are hard-coded as I.O. for banking. Rude, number one, but I get it. All right. Next one. All right, A9. Oh, you know, let me workspace, export labels. Whoa, that's dangerous. That's dangerous. Might want to mention the table. Yeah, probably. Code. NAS and then StudyBox. Labels, save, replace. There is a table at 140 that, what is the value of that table? What are the values of the table right now, actually? Okay, so that's sprite slots, right? And that allocates it to a Metasprite ID. Yeah. That keeps track of sprite allocations. Table your ducks were already mentioned, as in putting that into the label comments. Oh yeah, that there. Yeah, Metasprite ID, right? And a label. Metasprite ID. Each byte corresponds to a hardware sprite. And the value corresponds to a meta sprite. That hardware sprite is a part of. Now, this isn't really header data then. This is, well, yeah, it is. Okay. This location is pointed to by a table at what, 6980, I think it was. Are these still loaded up? I don't know. These don't look. This doesn't look right. Yeah, I forget what the other one is. That was 6800. That was something. I don't remember what. $263. I don't know. I'll come back to that eventually, maybe. All right. 0x-A9. Yeah, we'll want to. We'll dig into this deeper eventually, anyways. Right. And I've needed to write like documentation for all of these opcodes outside of code, right? That isn't like buried in a label file or in the disassembler code or whatever. So that's kind of like the start of what this is, /notes, whatever. So using XFC, yep. You should be using DWM. Why? Hey, by the way, Commodore. Why? Minimalist dynamic window manager. Nah. Yeah, I tile my terminal, sure, but for terminal stuff, like, that works well. For non-terminal stuff, absolutely not. Absolutely not. I cannot do a tiling window manager for non-terminal stuff. No. Funny thing that because the video chip can read from most addresses in the character ROM and RAM, you can store the graphics in the same address as the kernel ROM without them overlapping. Oh boy. Fun. Good thing about the kernel is that reading the keyboard, disk drives, and clearing the screen, etc., are all done for you. Yeah, because it has an OS for you, right? I got a famous got a famous story in making Tetris music for the Tetris thing. Oh, nice. Nice. Yeah, I I still only have like the like very basic, shitty Tetris theme MIDI whatever in there. I haven't got anything else in there yet. I still have a lot of cleanup to do in that ROM. I'm not done with it, but I do need a little bit of a break. I'll probably do a bunch of that stuff off stream though. You know. All right. A9. Where was that one? I don't have. God damn it. I don't have a label for that one. All right. 6079. What is this? Table? No. That is right in the middle, not breakpoint, of script data. That's not an actual table I can put a label on. All right, so 6079, 67 9. This guy right here. Hit a breakpoint on the read. Go. All right, we're gonna turn the audio back on, and we're gonna see how long it takes for that to trigger. All right. Delete that. That was that one. Okay, I'm not sure. What the fuck is this? Go to location. I don't care about that anymore. All right. Where we want no. Delete that. Delete that. Okay.
English Power Trial 6号
Bam. Okay. We hit it. So before all that, type into my stuff. No, I should have been going to the 9.7. Oh, Jesus. Whatever. Because it did whatever the hell that was. Juno the Metasprite. Which was her mouth. All right. A 2x2. It also drew some her arm. That changed, right? Did that change? Dear pointer. What the fuck? Deref inline pointer negate. Oh, I hate that. Oh God. All right. Anyway, we're at A9. No, we're not at A9. We're at A9. Okay, whatever. We're going for A9, I guess. It's fine. It's fine. All right. Bam. Edit label. Handler. A9. What's it doing? Who knows? Swap to bank 0. Load that byte. Branch equal. Nope. Decrement X. Okay. Loading up a table. 6C01. That's in a different bank, though. Oh, no. Because we're... Oh, God. We are... All right. Edit label. No. Yeah. View memory. 6C01 at X. Oh, God, I don't even know how big that is. How big could that be? I don't even know what that's for. Table 601. What is it? I don't know. Load that. Compare that to argument. Hang on. Let's argument count and all that. XA9. One argument. All right. What does arg A do? Compares it to a table. Branch equal. Down here. This is a loop. Edit label. Final occurrences. That's something specific. All right. Okay. There is the table 61. Says pointer that this table looks like it's copying a header for NAND or sprite data that is currently in RAM. Okay. On the phone, the Commodore 64, they ran out of stuff to fill the memory map with, so C1000 through CFF is just unused RAM. Oh, nice. Unused ROM or RAM? I've been thinking, I don't see a timeline where Linux isn't seen as a legitimate platform in 20 years. It's already at 6.1 on traffic in the US government websites. Valve's efforts, Microsoft care more about Azure and Office. No consumer pays for Windows, and Windows making most of its money from data mining, and data mining doesn't even pay Facebook and Apple as much as Facebook. Yeah. Yeah. The year of the Linux desktop, right? RAM because of the banking. Yeah, Linux is taking a foothold, and Valve is a big part of that. Just bank away all the I/O, basic, and kernel. Just get it out of here. Yeah. All right, I'm gonna hit play on my music again. Okay. We've got more tables here. Let's just do this real quick. We're just going to go to the end and see what it does. First and foremost, where's the tile viewer? Tile viewer's over here. Sprite viewer. Oh, these are hidden, so they won't show up next frame. He's a bored millionaire. Yeah. I want the tile viewer. Tile map viewer. This one here. Okay. Move to our arm. And it did not advance the page here. Okay. So that is just like update. Yeah, I'm gonna say that's gonna be update or restore. Hmm. Yeah. What the fuck was arg again on this? Load that compared to argument A. That's a table of some sort. Well, obviously a table of some sort. Branch equal. What do I compare branch equal? It's for x and it clobbers it immediately. Well, no, it grabs x, actually. So that's the index in there. Search table for a given value. If found, do something with it. Yeah. So it searches the table for a value. Oh, yeah, okay. So this one... Right. This table is an index of things to look at. Of IDs or whatever. Like maybe screen IDs or something. Or changes or what have you. We'll call them deltas. Right? And this here is a pointer to the delta data. Pixel the tile, that gets it, the position. Covers something to... Yep. Edit label. Arg A is delta ID. Data ID, delta data ID. Yeah. Into 6C01. I need to inspect that while when I'm there. I can't do that here because the bank is different now. Let's reload that. Let's just break on handler 9A or A9, excuse me. Similar to assigning a metasprite to a given set of hardware sprites, script still refers to it by metasprite ID, so it has to look up to figure out where to modify stuff. You know. So it didn't call it to move her arm. So this has to be like a restore. Maybe? Because that other one, that's probably what this is. This is probably, yeah, draw metasprite, waiting for some tape bullshit, draw the arm, Wait for the tape. And this is restore arm as where it was. Also, this disable sprite stuff, and then the call ups. Oh my god. Yeah, there's some animation bullshit in here. 9-7 is temporarily draw over, and then A9 is restore from that. That's what it seems like, yeah. Yeah. Okay, so we're going to swap that. This table right here. Memory viewer. Yeah, so it's looking at number 2. All right. Load that, branch equal. It's not, so we're going to decrement. It's underflow protection, I guess. Loads up 2. Compare that to argument A. That's weird. Branch equal. Yep, so we found the thing in that table. In this table here, edit label. That is going to be table 6C C41. That is at least 2 bytes. At least. That's these guys there. Looks like a pointer, right? So we can get rid of all of these guys, by the way. Delete all those. These pointers we're also going to get rid of because I don't need those now. Okay. Pointer 883. There's another one. Table 6cc1 is at least 2 bytes. I can't pull off all my thoughts. Probably an opinion confirmation by watching 97. Yeah. Mm-hmm. All right. Pointer A3 6045. CD45. So that's whatever that is right there. That might be header data. What Yeah, it's gonna be header data. Decrement X. X is 0 now. What was X? Sure. Load Y2 at that pointer, 64.7. That read that one, that 0. Store that there. And you're 85, sure. 85 is a few long. 4 bytes? All right. 85, 4. That's, nope, that's not the right character. There it is. Code Y. $58. What up? That still see. CC. So okay, there. Loading up these guys. 2058. Try that there. Tile. No. Hex of 20. It's 32. So that doesn't look like a coordinate. Point 83, hit a copy. Okay. What does this do? Right state of view, point 83. Which we're already looking at. Writes to table 6D1. Zero 61. That's in main RAM. Well, yeah. How big was that one? 6 bytes. View. 4, 8, 11. Copying header for name tool or sprite data that is currently in RAM. Okay. D1. Oh, 6. So it overwrites where it just grabbed that information from 8.3. Okay. Huh. Load X and A. X is 4. A is that one there. JSR over here. All right, what the fuck does this do? Oh, God. What? Push A. Okay. And it with 1, the low bit. 0. Okay. Branch equal. What the fuck? 6, 8, 6B. That goes over. Okay. Clear carry, add 1 LSR. So that what the fuck? The LSR before or the or after the add? Okay. Two. Store that there. Pull A. LSR. And with 1. The next byte. Next bit. Branch equal. Nope. Some bit manipulation nonsense. Nestrus Orc isn't working. Uh-oh. Nestrus? I don't know if I've heard of that one. 4, 5, 6, 8 plus 0. Some IO in byte 4, 5, 6, 7. I think those are just overlapped variables there. I feel like how modern games allow you to 1v1 random people and train and stuff, but Nest Tetris. Oh, okay. I see. So it's Nest Tetris multiplayer, basically, yeah? Nest Tetris multiplayer. Why? Why are you still pinging me? Alright, so I'm not going to worry too hard about that. 567, 456A, something different. Okay. Load that there, store that in there. Okay. C, D, C, E. I'll call these bytes for now. No. 4, 5, 6D. Can also link up a normal console so you can play matches on OG hardware. Ooh. 6768 could be an output word. They could be, yes. That's why it said it might be. It's probably overlapping bullshit, right? Byte 4, 5, 6E. Load that up. We're gonna store that. Shifted a bunch. Overwrite that value. It's 4 plus 5. Shift that a bunch. Store that. Load that. Shift it twice. Store that. Pixels to tile. Pointer 83. 61. That's just work use give have a too bad gateway internally. Uh-oh. Yeah, they're down. Wait, what the fuck? Hang on. Load. Okay, I was looking at something else. Yeah. Load Y. Where's 66? Okay. That's going to be an array, actually. What's the guy play against so bad he crashed the servers? Oh, no. How could you? What is this? Why is this green? Execution. Right, that's the NMI. Right. Oh man, I forgot about that. Right, that's where I first saw that that used were the NMI handlers in RAM. Thank you for the follow, appreciate it. I guess my friend who has never played Tetris and a best of 5 match. Yeah. Yeah, how'd they do? How poorly did they do? Alright, so it's gonna store it there. Increment, compare to 6. Loop. Sure. He scored 0 points in 2 of the games and only 400 points in the other. Oh my god. Is 400 is one single. Break him against the coals. Load 3, store it there. Load 7, Workaround Bank, Lower Grim Swamp. Whatever. Copy something, buffer some stuff. Yep. JSR over here. What is over here? What the fuck is this? That's not data, is it? No. Oh, that's code. Yeah, okay. Label 6F02. For me, below 150k is a bad game. When I look at these performances, I am baffled. It's rude. All right. 456F. Probably a bite. Byte. BYT 456F. In a 1 hour session, I can normally score one game in the 5 to 600k range. All right, not bad. Huh? Yeah, I can see how 150 would be a bad game then. Yeah. Bunch of moving shit around. Multiplication. All math shit. Whoa, 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 what the fuck is this? Oh, God. 79C. What the fuck is that 79C? Label 6F77. Nothing. 25 bu- Okay. Okay, I guess there's not nothing in there. Loop on that flag, so that's going to be waiting for something to draw. Maybe. I thought it was. It. Oh, okay, yep, so that's. Yep. Now these are each of these are taking a frame, by the way. Every single one of these is taking a frame. Every loop here. That's horrendous. Oh. Yeah, like 8 frames. Yep. Yep, just to restore that little itty bitty area. Yep. This is a loop, right? Yeah. Everyone on the Discord server is talking about doing stupid regional. What do you mean stupid regional events? Well, you suggested the Sealand regional. Sealand? Where the hell is Sealand? What is this now? Oh God, what? That's a new pointer right there. Pointer 5A. Oh, I need 2 bytes. That's used in a few places. Okay. And, oh God, that's not just used as a pointer either. Fuck. Sealand is the place Copenhagen is located. Ah. Gotcha. Label 7037. Jesus. Edit. Label 6FBA. The Principality of Sealand is a self-declared micronation on Ruff's Tower, a World War II fort off the coast of the UK. Ah, gotcha. All right, so then this stuff. Did that swap name table bullshit? No. I don't know why it looked like it did, but I don't think it did. Pointer 5A. 64.5. That's that tape. That's that header. Whatever the hell. 64.5. That's this shit again. What up to? 64.7, so that's the 0 and 58. Is this a loop? No, that's pretty far down, actually. Okay. Edit this. Word 4877. It's 2 bytes, though. 64.5. That's not a hard-coded thing there. What the fuck? 64.5. Okay. Why is that hard-coded? That's in the middle of fucking RAM. What? All right, we're gonna come back to this opcode. Which one was that? A9. Name table restore operation. Writes. Smaller updates to the name table for animation purposes. Okay. So the other byte that I actually wanted to do, 9.7. All right, handler 9.7. Do I have that? I do not, because of course I don't. Why would I? Location. Turn that on. Delete that shit. Reload that. Let's turn off the audio too. I don't need that on. Okay. What? Oh. No. There's been a coup, a hostage situation attempts to... Wait, what? The guy founded it wanted to set up a pirate radio station, but realized that it was outside the UK's territorial waters, so he declared independence. So far, there's been a coup, a hostage situation, invasion attempts, and a de facto recognition from the UK and Germany. Really? Huh. Interesting. All right. Memory viewer. Woo, look at all that. We'll clear that. All right, so the address I want to look at is 6044 97. Enter breakpoint. On the read. Over here. Disable that one. Go. So go. All right. Edit label. Handler. 9-7. We're in a bunch of new code here. Oh my goodness. Look at all these labels that aren't. Oh God. Is this all data? That's not all data, is it? No. That's motherfucking code. From handler DE. Whatever the fuck that does. Yeah, that's NOP, isn't it? There's some audio shit. All right. What is it again? Control 1. All right. Let me refill this water real quick. I'll be back. I'll see you hit the bathroom. I'm back. made like immediately before stream too. What the hell? Alright. It's officially down. Uh-oh. Alright. Oh. That's F11 on the wrong window. Label 5F39. Oh, this. Long jump. Take control cache. What the hell? Set to 0 if tape NMI is set up. Set to 1 if not. Tape NMI or tape IRQ? Turn off NMI. That does turn off NMI. Okay. And okay, it is NMI bullshit. Oh, it's the well, the engine NMI. Maybe. Why is that part of this handler? What the hell? I could be waiting for some I don't know, like waiting for it to take. That's weird. I don't know. All right. Load argument A 3. Oh. Cool. Okay. Two arguments. Arg A and B. Load that. Compare it. Alright. Label 9F4. No. 5F42. LA. No. 6. Where is that? A ways away. Okay. Like the end of it or something like that. Label 615A. All right, branch. Yep. Oh, branch carry clear. Okay, so we're not branching there. Okay. Another array plus 2 compared to 1. Branch equal. Hold that. Store it there. Is this like... Load that. Oh, my buttons are coming off. Give me a second. Okay. Load argument B. F. Store that here. Edit label. Byte 4598. handler 9-7 stores argb here. Ramazan, how you doing? Welcome. Yeah, let me do this actually. Add a label. Well, no, I won't put argb on that. No. 11. That was the whole opcode? Wait a minute. No. That didn't do anything. Potentially set up tape shit. And then whatever the fuck this is. But only if arg is greater than or equal to 3, and other way it's not. Right. So, like, on this call, it didn't do anything. Well, it set up some stuff. Barely. But there's so much code it skipped over. Oh my god. Jesus Christ. Okay. Because now it's going to wait for tape. Ugh. Condition sets up NMI stuff. Depending on byte 0740. Memory viewer. Ugh. If okay, come to here, 4D. All right, and label label 5F4D. Change our check for 0. Checks for 0 in 44F9 through FC. What? FD. So it's looking at a few conditions. Sets up a bunch of stuff. Yeah, so that if arg A is not 3, set up some more stuff. What exactly? I don't know. Wait for tape. Pop and store. Destination is inline word, writes word from stack to destination. Yeah, so that's going to be that. Okay. Pop. What a good pointer. Show that there. Decrement Y. Good pointer right there. Argument A is 73dB. Yeah. Okay, so let's have a look at that in memory viewer. That's part of the loaded code. Tables and shit over here. 73D B right there. Stack pointer is 7 over C7. So it's going to store F at that point. The word F. Load coup pointer, add 2. Yep. Set carry. Load stack pointer, subtract 2. Load up the stack pointer. Oh, that's zeros, actually. Okay. Push word to stack. $104. Oh, no. That's pushing the inline word, right? Push inline word to stack. Okay. Get out of that. I got that right there, yep. Pop and store. Where's it putting that one? 73DD. Put right next to it. Right. Yeah. Oh, right, because that pushed some shit on top, right? Yeah, it pushed a 1. That should be pop into. That's what that should be. Pop. Yeah. Not equals to, but greater than, greater than 3. Okay. Yeah, I wasn't entirely sure on that, actually. Makes you send us some variables using inline stack and on stack values. Yep. Yep. A load store, basically. Yeah, because I don't think there is a set address to value, inline value, right? So they gotta do it this way, which is fine. That call, though, what the fuck is going on there? This guy. 6FCC. CC0CC. This here. Oh God! Jump switch. Yeah. So those are one of the pointers that we one of the values that we stored. 73E1. This one. Call, yep. Deref pointer. Code as a pointer, deref it. That pushes the value to the stack, right? just go ahead and do that. Puts out 1. Yep. Jump switch. Load Y. Inline argb, default case and max size. Arg A is switch value. Arg A is shifted for use as index into pointer table. You know, Britt. Arguments. XC1. -2. Yes. What does -2 mean again? First byte is count, followed by number of words. 3 plus. Oh wait, no, that's these are inline. Stack arguments 0. 1. Arg A is used. Yep. Okay. Inline arguments 3 plus. Arg A. What is Arg A? Arg B jump? What the fuck? Load up A. Branch equal. What did branch equal do? Here. Arg B. Wait a minute. No. Hold up. Do I have that wrong? Because this one... Where is that table that has all this shit in it? Because I might have that just wrong. Does anyone remember where that is? Tape control, observe command, something tape for more reference, IQ handle behavior, application register, bank 0 locations, 0 page, RAM locations, picking RAM locations, simulations, yeah. Firmware org. No impurity addresses. Looking for C1. Well, actually, what's the format of the things here? Stack pointers this side of the landing word at 6,000. Typically, the address is the first byte word after the end of the script code. Stack expands upwards, and the stack pointer is the address of the first byte beyond the element. And the stack is upwards empty. Stack, yeah. Script bytecode tables. The interpretation of bytecodes is primarily controlled by 2 tables: a table parameter result, control bytes at that, and a table of handler function pointers, control bytes. B211. C1. 1 argument? but it's using argb. Really? Let me double check that table. Come on. Where are you? There you are. Word 6B. No, not that. God damn it. Is arguably return value perhaps? Maybe just something uses temporary. It's loaded. It's loaded immediately. So here's the handler. Load Y, decrement Y. Oh no. Okay, you're right. It is inline to argb. Oh, it's a temporary. Never mind. Never mind. Yeah, it's a temporary. Okay. Anyway. All right. So this code pointer at Y 6. Viewer. Store that in 0. Decrement Y FF. +1. Branch equal. Nope. No. First by is count, followed by that number of words. Inline argv, default case and max size. Default case. Oh, so the default's at the end. No. Argv switch value. Okay. Oh, that was the value at that pointer, right? Hang on. That's a 1 byte index though, right? That makes sense. It's only 1 byte index. Yeah. Yeah. All right. So compare that to 6. Branch equal arg A is B inline, which is the default, I guess, right? Branch plus arg B jump. Wait, what? Oh, plus not equal. Right. Duh. So this is default. Default case. If out of bounds. All right. Decrement that. ASL clear. Code pointer plus 0. Add that. Was code pointer incremented past? Yes, it was. Okay, code pointer is incremented past the default. Yep. So this is just gonna go to 6FDD. Inline argument. 6F DD. Argument A. Oh, wait, so that jumps after that pop. That's all that does, isn't it? Maybe? Why is that so weird like that? Know that arg. Starling code pointer. Starling code pointer. 6FDD. RTS. Because it's the one before the next. Why don't I deref that correctly then? Why do I get these right? What the hell? Call, no, it's a C1 though. C1, switches. Tokens, script labels, found as true, offset equals address. It's because it doesn't start on one? No, that just goes to... No, that doesn't skip the pop. That goes right to the pop. What the fuck? Because this... Because the code pointer now is 6FDD. Which is is not incremented to the next one, because the next one... Is it? Let's see what happens. Bit 8246. What the fuck is this? Label 82444C. I don't know what the fuck that actually is. Branch equal. IRQ happens. I don't actually care about IRQ stuff. Okay. JSR set return codes. Takes in arguments and puts them on the stack based on bytecode metadata values. LSR, branch carry clear, carry is clear. LSR. That's RTS. Nothing. Oh, yeah, ugh. I forgot about the string stuff. God. Okay, VM code loop. Up there. RAM bank beach. What the fuck is this? That's negative. Chop off the top bit. Shift it left 4 times. High nibble to low. And store that into RAM bank B. Clear this high. What the fuck? Okay, doesn't know anything. But that French equal to loop. Label 824B. No, it is looking at that code pointer. Am I disassembling that wrong? TD01. 75-2. Yes, I am disassembling it wrong. Okay, that's what that is. Counting words. Raw input. Hang on. 1, 2, 3, 4, 5, 6. This equals 2. Hmm. 6F DE and so which is weird. Yeah. So this is janky shit for some reason. +1. Args byte val L. No. Plus equals 2. Where else do I increment I? Right there. At the top. So I need a I just need to subtract I minus minus for a correction? Count +1 words. Vector's default case. This one is probably wrong too, honestly. Okay, that fixed that. Where's one that is -3. Call switch. These are weird too. 6512. EE? Is that what that is? EE, okay. 6512. So I have 2, 1, 7, 2. No, B7, excuse me. The last one here is 8, 5. I am missing. No, CB 8, 5. Yeah, that 7, 2 is gone. Yeah, so it's the same thing there. Okay, and while I'm in here, -1, null terminated. Push data. Seven three 7 3. Starts with BB. All right, 738E. Okay, that one's correct. Oh. Word popping. I think that is my shitty setup. That's gonna be some scuff that I've got. Sorry. That one's on me. Hello, by the way. Welcome. How you doing? No worries. Yeah, no worries. So that one's good. All right. So null terminated was all right. But the inline stuff wasn't. Okay, so we're gonna make that again. Over here, redo that. Edit. Call something. Oh, they call switch. There we go. Dear pointer inline. Dear pointer inline? CB8. What the fuck is going on here? What? Five. 1, 2, 3, 4, 5. Wait a minute. Call switch. Count then. Count plus 1 words. Extra is default case. What? Default? That's why they design it like that? So the jump has the last in the length as the default, where this one is the next outside the length as the default. I hate that. I hate that. Let me double check that though. Handler EE, where are you? Call switch. Location. Length and default case inline word. Okay. Inline byte to argb. I need to do this. Does it ever happen? I wonder if this script is loaded for the entirety of the No, there's a few of them. All right. Are we still in the same script? We're still in the same script, aren't we? Jesus. That flashing, my God. It's actually scrolling, all right. When does this actually happen? My God. Guess time to rewrite the firmware, right? Or at least optimize bits and pieces here and there, right? Whoa, there it is. Okay. Jesus Christ. Took long enough to get to it. My God. All right. Code pointer is 6F3B. A. Oh, so we're we're in this one then. But we're no worries. See, this one at the end of it's weird again. Weird again. Like D502, like that's assembly. That's in the firmware. Like that doesn't make any goddamn sense. All right. Load one. A. Store that there. Decrement Y. I don't know why it does this loop, by the way. Like, you don't need loop there. Chunk of script and... All right, well, let's... D502. What is there, then? I'm going to go to D502. It's not code I've been to, but it doesn't look like data. It jumps like right here. To the 45 it jumps to. And AD, what's that in the thing here? Absolute. 6645 F0. Disable sprites. I don't know. That's fucking weird. I don't know. The code announcer should be yeah, it shouldn't be a banking thing. Cause I'm interpreting this thing right now. Unless there's some provisions in here for that. No. What? All right. Let's see what we got anyway. Load 0. Store that into C plus 1. Load A. 0. ASM. What the fuck? Rotate. Increment the code pointer. Yeah, okay. So now we're looking at 6F3C. Look at that in here. 6F. 6F? Oh, right, because we jumped way the fuck down here somewhere, right? Yeah. 3C, so looking at the 54. Load argument C, add carry the code pointer. Oh, right, so this is getting the last. Yeah. F50. That's a D502, isn't it? That's the D502. Okay. Load argument A. Branch equal. Jump arg B. Compare B. Arg B. What was arg B again? Whatever's on the stack, I guess, yeah? Down here somewhere. Seven D7. I don't see A on there anymore. What the hell? Or B is the switch length. Oh, is it? Oh, yep, yeah, the switch length. Yeah, never mind. Yep. And arg A, other than this guy here, from the stack. Okay. Compare that. It's not equal. Branch plus. Jump arg B, not plus. Which was let's go back. Compare A. Make that B for shits and giggles. Let's see what happens. Okay. So we're forcing into the last argument there. So ASLA. All right. No, ASL arg B, sure. So next to 14. Load the code pointer. Add the low byte. Store it. No, that's not a default case. That's just the end of it. That's not an address, that's data. What the hell's D5? D5 is wait for tape. It's not a +1. That's not an address. That's just data. Yeah, it's not. It's a relative jump, not an absolute one. Adds argb to the code pointer. Right. So this one, there isn't a default jump or a call. It's don't call any of them. Default is no call. Skip code pointer to after args. That's all that is. Typically it adds argv times 2. Yeah. It's fine though. Key instructions. Oh, I already have that open. Like 2. But with no default. Code continues after list on no out of bounds. Switch with the fall through while the other one defaults to one of the cases. That's what it seems like, yeah. And now I've got a lot fewer missing targets here. Malik, how you doing? Trying to catch up where you doing? Yeah, no worries. I am reverse engineering some stuff. Give me 1 second here, though. Offset there. Call absolute. Whoa, what the okay. That. I don't like that. I wonder if this is like a bank switch thing. Yeah, so what I'm working on right now is for this thing. This is a StudyBox. It's a device for the Famicom, like a learning device. The program's the learning device for like English and math and science for third, fourth, and fifth graders in Japan, right? Back in the early 90s. Yeah, educational machine. Then the lessons came on tapes. And frogs. Yeah, frogs. It's part of the science one. Excuse me, the entire program for the lesson. And Johnny, yep. Hey, and Luke. Yeah, so the entire program for the lesson is on the tape. And it is all a very special format. So all the images and audio stuff is on the tape. And there's a domain-specific scripting language that's interpreted in the ROM. That's how it does all the animation and all the logic for that given program. It's programmed in this scripting language. So what we're doing here is we are reverse engineering that scripting language. So I've got the emulator up right here, where we're stepping through a bunch of this code. And I've got up here is some code to decompile the script. And down here, we've got the actual decompiled code. Disclaimer, the physics on the balls on the math tapes should not be used as a representation of real life. Now, unknown FE. What the fuck is FE? Don't I have that set up over here somewhere? FE. Go to location. That was at least 5 years ago, I think. At least. StudyBox FE. Yeah, so before I started work on reverse engineering this thing, I had never heard of it either. I've got one right here. So I was sitting in the NestDev Discord one day, and Sour, who is the guy that maintains the emulator that I use, Messin, he was lamenting over the fact that a lot of the feature requests that he usually gets for the emulator are, hey, can you implement this obscure Chinese multi-cart mapper, pirate mapper? And you know, he didn't find any fun in that, right? Because it's always like, oh, it's like this mapper, but let's say a different address for the bank switching or some bullshit, right? Or the bank switching is a little bit weird, but that's all it really boiled down to, right? And just offhand, he just goes, I wish someone would get the StudyBox and figure out how that works. And I go, what's that? I never heard of that before. So I went up on eBay, and I searched. I went, ooh, there's one available. Oh, it's $50 though. I don't know if I want to spend $50 on this. So I slept on it. I go, if it's still there in the morning, I'll grab it. I'll pick it up. It was still there in the morning. I have since spent hundreds of dollars getting weird, getting more of these, and come on. Let go. Acquiring a bunch of tapes. I'm not sure where the box is, but also a bunch of manuals. So over the last few years, I've been working on documenting, reverse engineering, archiving this little device. After you figure out what you want your construction to look like, are you going to have go tools to be able to decompile the ROMs in the new language you make? That's kind of what this is. This is a debugging kind of representation of it, but that's what this is already. And I'd want the other direction as well, the compiler for it. You know? 5 years ago. I've been doing this for too long. Let me actually break on it, because I'm curious on what that one is now. I got to reset the ROM though, because I screwed with it. I was at 6F75. FE. This guy. That's 7.4. Wait a minute. Oh, yeah, that's it. At a breakpoint on the read. Okay. And then we're going to go ahead and reload that ROM. We're just going to let it go until it hits that, which is going to be a hot minute. Just rewrote a bunch of shit. Oh, laggy. Yeah, just swapping that out. You know what I actually need to do? I need to break on the handler itself. Because there's no telling if it'll actually... Well, it might hit it before that byte. FE. Yeah, it's 11 times it happens. So okay, so that's not the only place in that script that it is, that opcode is. Oh my god, that flashing! Oh my god, it's so terrible. Oh! Oh! Wait a minute. It's reading that specifically as data. Because I do not have that bank swapped in. I've got that as CPU memory. Shit. Oops. God damn it. That guy. View memory viewer. Edit breakpoint. Not CPU memory. Work RAM. Whatever it currently is in work RAM. That's what I want. You bastard. No. Hey. God damn it, whatever. All right, just handle or FE. Fine. Some of the characters look like a similar art style as Doki Doki Panic. What? Sure. Found a clip of one of the PowerPC IBM machine he got. He said, I want to get that working to use on stream. It's been over 3 years since. Yeah, shut up. Can't say I understand. I barely understand what I'm doing. All right. Reverse engineering is fun, especially on the NES. Yeah. Sorry for the dumb question. What is this disassembly software? You're fine. So what I have on screen right here, this is Messen 2 specifically. It's a NES and Famicom emulator. The stuff I've got in the background, that's stuff I'm custom writing, specifically for StudyBox stuff. But this window here and this shit here, this is all Messen. It's right here. Oh! Okay, we got to one. Oh, it's drawing this shit up here. Okay. All right, where's our code pointer right now? Code pointer 6F24. Okay. What does that look like over here? 6F. Here. All right. All right, loading up argument A. How many arguments does this guy have? 4. Okay. A, B, C, D. And it with 3. Store that there. Load B, and it with 3. Store it there. C, and it with 1. Store it back into C. 55C plus 1. Branch not equal. Over there. 6F24. That's past a couple pushes. You're right, what the fuck? That is weird. I'm not going to worry about it for now. I don't think. 7-4. It's 2-3. It did read past it. Does it have inlines? Is this supposed to have inline? I've got it set so it doesn't, apparently. Inline operands, length and bytes. I could just have it incorrectly set up here. What's FE? Has an additional 16-bit inline operand. God damn it. So that's this one, right? Make, come over here. Q, do that again. Woo. There we go. FAR 746F. Oh, there's still one more unknown target. I'm sorry, what? Jump absolute 0? I want to actually learn assembly to make stuff on the Commodore. Ooh, might as well start reverse there, maybe. Yeah, nice. So check out Old School Coder on Twitch. He's reading a book about Commodore 64 assembly. Ooh. Currently teaching a beginner's course on Monday and Wednesday. Nice. All right, where was I? Unknown FE. FE? FE. Wait, what did I just, how the fuck, what did I break? 6F24. Oh, there it is. XFE, that's why. That one's not impossible. Something stores script code to 0 page, but seems unlikely. No, I think that's a script address. Oh yeah, because no, that wouldn't be a script because I'd have to start at 6,000 at least. That's fuck. Maybe it's just data. Maybe it's just data that it's trying to interpret as code. I don't know. All right. So what is this doing? Pointer 54 is used. Okay. (746F) load Y. Increment. Human reviewer. Are these like sprites or something? What the hell's going on here? Okay, so it actually might be sprites. Because it's going to be drawing something in here. That it doesn't have in character ROM right now. It draws characters, like Japanese characters, kanji. Does it actually use the font on the in the firmware? Oh my god. Maybe. Okay, we're gonna find out though. Load that 64. Store that into argument D. Increment 4C. Compare that to FF. Branch equal. 4.6. That's RTS. I see a JSR there. Oh boy, we're gonna see what that is. So in D+1. Transfer Y to A. Push it. JSR to whatever the hell this is. Center point, how you doing? Edit label. I beg your pardon? Label 0047. Hot to RAM bank 0. Okay, so that's going to go away. Load up argument D, 64. Store that there. And there. JSR over here. Oh, 0, clear up some stuff. 6, 7, 8. Edit label. 7, 8, 9. Let's call this array for now. 4, 8, no, 4, 8, 6, 7. 3, no, not 2 bytes, 3 bytes. Okay. Load that, compare it to 21. Branch carry clear, branch equal, branch carry set. Compare it to 4F. Branch carry clear. Compare it to 2.9. Jesus Christ. Branch carry clear. No, compared to 2D. Carry clear. Branch equal somewhere else. Jesus Christ. Label 033317. No. Edit label. Delete that. This guy. Edit label. Label 324. Missed a 0. And this guy, edit label. Label 0327. Okay. This is going to be code as well. Label 0377D. Label 041F. Okay. Compare it to 30. Branch carry set. Subtract 30. Let's see. Let me array 4, 8, 6, 6, 7. 3 of those like that. Okay. So that there, load that, so that there, multiply. Result. Add, store, load, add 0, store. LSRA, clear, add A, store there. Compare it to 10. Branch carry clear. Nope, 6, damn it, thank you. Load that and it. Store it, load that, store it, jump over there. Label 037A. At that label. Label 0443. Okay. Load X. Shift. Rotate. Decrement X. Branch not equal. That's a loop. That label. Loop. Add 80 to that. Store it there. Compare to 80. Branch carry clear. Compare to C0. Branch carry set. Load 2. Store it there. Compare that to 4. Branch equal. Store that there. RTS. Bunch of math shit. Load that, branch not equal. Load that, branch equal. Shift by 5, let's multiply by 32, line to offset maybe. Ooh, I wasn't paying that much attention. Byte? Oh, byte 4873. Multiply by 32. Line offset. I don't know, we'll see. Branch equal. JSR to this. Swap ROM bank. Let's fucking go. Oh my god. Label 0161. That's okay. That first one's ROM bank. C2. Which one up here somewhere? C2E0. Yeah. Zero. Thank you. All right. Swapping the ROM bank. Current ROM bank 1. Oh, so okay, we current ROM bank F. Or swap 2. All right. The low ROM bank is at F now. RTS. What is there? CPU memory. Oh, 8,000. Let's fucking go! It is. So these are all 1 bit packed, right? Oh my God, I love it. So programs do actually use this. It's amazing. Yeah, so the ROM char set is used. Fucking beautiful. Yeah, so this here, edit label, swaps to the firmware's char set. Okay. Load that byte, decrement. Load that in X, decrement by 1. Table. AE. Okay. So right there, load that, store that in. There's memory 6.2. What's the Oh, it is not. This is the data bank of shit. Actually, what? That isn't tile data. Could that be like just straight name table data? You think? Tile index 4. No. No, this is probably just scratch data then. All right. Edit label. Table 6280. I should probably reword that stuff a little bit, but whatever. Like that should probably be like the offset in work RAM, not the CPU address, but yeah, actually let's hang on. Table WR 0280. How about that? This guy, in a label. Table WR 6400. WR 0480. No. Edit. 400. Yeah, I got it. All right. Store it there, load that. Store it there, load that. Store it there. Okay. Those are all probably at least 16 bytes, but I don't know. Transfer X to A, ASL. Put that in Y. Load that up. 6.3. And 3.1. So this is at least 2 bytes. Edit label. Table, work RAM, 0300. At least 2 bytes. Right there. That, store it there. And with that, JSR over here. Label 0199. There's another RTS. Nice. Label 0257. Transfer A to X. Push it. Load that, store it there, load that, store it there. Okay, word 50. $91.60, okay. Starting there. I need a like decent grayscale that like blocks out shit, but I don't have those right now. Filter. No. Tile layout. I wish I could do like the like 1-bit stuff on this. It's grayscale. Yeah. How did I even do that? Yeah. I've had the same trouble, Joe Mega. Same trouble. All right. Load Y 0. Transfer over to here. Transfer X to A. Push A. Transfer Y to A. Push A. Okay. Backing those up. Load that. Compared to 4. Branch equal down there. Load that. Store it there. Load that. Store it there. 56. I should also probably like, well, yeah, probably be like listing out what each of these routines actually like uses for variables and all that. Just over here. Let's switch the data from the. Okay, I've already had this for other stuff on the menu. But this is 1-bit data, so how's it going to handle that? Let's find out. All right, 9160. Load that. Store it there. 56 is at 4528. 4, 5. 28. Did it right there. Seven, 8. Load Y 0. Load A 0. Load X. ASL. A. Push A. Branch carry clear. Down here. What the fuck? Four, 5, 5E. 4, 5, 5. E. That's these guys down here. E1. Or F. So it's this guy and that one. Alright. Load that. Store it there. Shift it. Rotate it. Shift it. Rotate it. What the shit is going on here? Am I looking for an exploit or fiddling around? I am figuring out how this engine works, essentially, right? The end goal is to basically be able to write programs for the StudyBox with its like scripting language and all that kind of stuff. So there's a bunch of things that I don't know, that we don't know like what they do, right? These unknowns, right? This shit here. This is the script right here, by the way. This is the stuff that it's running. So I want to be able to create these scripts. But in order to do that, I need to know how it works. So I'm figuring out how it works, right? That's the basic gist of it. Yeah, no worries. Okay, so all that's going to do not much of anything because it's shifting and rotating zeros. So I can't tell what it's actually doing there. Really? Yeah, everything is 0 here. Okay. Load that word. Store that into 56 plus 0, 4528. Transfer Y to A. Push it. Transfer Y to A. Clear carry. Add 8. Why'd that jump way up there? Oh my god. What the shit is this? Is this like writing on top of something else? It is, isn't it? Thank you for the follow. Appreciate that. Some kind of obfuscation taking place independent of some other. So okay, so what it's doing right now? So I've played through this before, so I know like what the ROM itself is going to be doing, right? So we got to a point where the scene has finished, right? In a second or so, or a second of playtime or whatever, it's gonna flash a little A indicating, hey, continue. Before it does that, in this little box right here, this little pale box, it's gonna write a character and a number. The character is over here. Right? These are packed as 1 bit per pixel tiles, not 2 bits per pixel, which is why they look kind of fucky, right? It's kind of why they look really weird. Oh, I don't know if do I still have YOCHR somewhere? Code NES iname YOCHR. I don't. I don't know what my old Windows code is. I wish I could look here, but I can't. Transparent? No. Yeah. If you have the raw data for the 1-bit per pixel tiles, I have a program that can convert it to a PNG. Yeah, it's in the firmware ROM. I mean, I've got the raw. I've got a program that can do it too. But I can't be bothered to actually go through it. Anyway. All right. Continuing onwards. Compare Y to 8. No. Okay, so we're going to put a breakpoint there. And for shits and giggles, we're going to look at the event viewer. Okay, we're up at the top. How long does this take? Oh, only a few scan lines. All right, that ain't bad. Video size 2x. All right. So that. All right, so that expanded. That expanded it from 1 bit per pixel to 2 bits per pixel. Oops. Can expand 1 bit per pixel tiles to 2 bits per pixel. All right. So that's one of 4 tiles I think it needs for this character. Edit label. Load CHR from ROM. There's a few of them in there. Okay. So 1, 2, 3, 4. That checks out. So we've got 4 of them, 1 for each quadrant of the character. Okay. Load that. Clear carry. Add carry. Yep. And we're just going to jump over this one. Okay. Now we're expected it to go, actually. I expected it to go right there. All right. $45.18. Okay, it's going to go up top. Oh! It's doing it vertically, isn't it? Okay, so this is going to jump over. And then the last one is going to go in that blank spot. There it is. Okay. Okay. Are there... I need to check the sizes of a bunch of these, I think. These being... these bastards. Full width, half width kind of stuff, right? These would count as half width, I guess. There's another character up here. That's for like Paige or something like that, I think, right? Oops. Hmm. 288, where's that? Where's that jump? Had to be up here somewhere, wouldn't it? 288, yeah. Compared to 4. 2 versus 4 tiles. 4 branches. Okay. Flow chart from ROM. That was just one of them, right? Okay. 518, yeah. So this is gonna do some whoa, what the fuck? 52. Wait a minute, where's 52? What the shit? Different Y. How many was that? 4? Why did I do that? Okay, it's word. What's word 52? Word 52. 0AE0. What? Add that, store it there. Load that, store it there. Add that. 1AE0. Oh, that's character RAM address. PV memory. I don't override that, is it? Shit, maybe. Let's find out what it overrides. All right. CPU buffer address. 1AE0. For 10. Hex 10. That doesn't sound right. Word 50 at Y. Oh, okay. 2 refs. View buffer address. Buffer data. Okay. 10. Add carry. All right. A1F0. Check one audio. What the fuck? That's not equal. Did I accidentally hit something else? What the fuck was that all about? Audio. $4,500. That's not audio. Is it? Loop. This loop up here. No, where was the other loop? Was it just this? One dB. Is that up here? Yeah, that's another loop. Out label. Loop. Outer. Loop. Inner. 6, 7, 8, 9. A, B, C, D, E, F, 1. Increment that. That's what increment. Okay. Branch not equal. That's not audio. That's just a counter, but whatever. All right, I'm gonna go down to here. All right. Buffer address. Set flag. Wait for that to happen. It didn't draw anything though. Interesting. Swap the ROM bank back. RTS, RTS, RTS. Oh, because it needs to do the other one. Did it update the tile graphics? Yes, it did. It updated the tile graphics. Okay. So now there's... I think it's going to do one more, actually. There's a loop. Aren't audio. More table stuff. Yeah. Buffer some PPU stuff. Buffer some PPU data and waits for the NMI to draw it. All right. This is placed it in a certain spot, I think, right? Something like that, yeah. Now it should draw it. Okay, it drew two of them. It's gonna write the scroll. RTS. Oh my god, what the fuck is this? What 20, what 5? What the hell? Got a 5, 7. Is that a loop? Nope. Loop there. Buffering the next bit of it, I guess. Yeesh. Actually, let's just jump out of it. I don't care. Set that. Looped again. Why did it loop? Three times there. Buffer. A buffer and right. Okay, so did that one. Loop. Oh, now we're much higher up in the call stack now. So we're back in the handler. Back to FF. Branch equal to RDS. Okay. Wow. Whew. I don't know what the fuck he's looking at. Yeah, basically. Hey, Mad Genius, welcome. Welcome, welcome. Okay, so what is my code pointer at right now? 6F24. Okay. So, somehow, he translated all this shit into draw that character there. But in order to draw that character, he needs to get it from ROM. All right, 746F. What is in 746F right now? Was that modified? I don't remember if that was modified. 7, 4, 64. Oh. Oh, right. I forgot. It's not mapped in anymore. Oh, God. I don't even know which one it was. It was those two. I think. I remember seeing those on there. 1, 2, 3, 4. Is it 16 across? 32 across. No, that ain't right. It was like down in here somewhere, wasn't it? Draw overlay character? The argument saying which trying to reveal ROM address? That's gotta be like ID or something of the character to draw. Right? I'm gonna call it like draw ROM character. Okay. Bunch of switches and stuff in there, so I'm not sure. Could be more general. Yeah. Xerox FE. Stack arguments. 4 inline arguments. 1 word. Yeah. Observed drawing a kanji character taken from the drawing a 1 bit per pixel kanji character taken from the SPX ROM char set. It drew a box, didn't it? I don't think so. I don't think it drew the box. I think something else drew the box. I think this drew the box. Or no, right there. Fill the box. 2x4 at maybe that's an address. I don't know. I just look like an address. Oh yeah, you see. What's the tile? Tile index 0. Okay, so that's tile index. There's probably some attribute stuff in there as well. I'm not sure what that other unknown is. Um, okay. How's it going? It's going. We discovered that this ROM does actually, this tape does actually use the character set that is inside of the StudyBox ROM. So it is used. It is used. I wasn't sure if it was or not, but it is, which is cool. Yeah. I mean, it makes sense too for what it's doing here, because this is something that happens a bunch. That's not what I want. This one, right here, where it like displays a number or some shit. So it's this and then a number. It'll display in a little bit. Wait, that and isn't there like the A button press or some shit? Here's B, A and B right there. Yeah, you can almost see the difference between them, but yeah, A and B are on that tile right there. And that's going to show up over here in a minute as a sprite. So if I just let it go. There's another one. Okay. Oh, because that's going to be for the one. Draw character. Wait, they duplicate feature and differentiate with grayscale? No. So it's a 1 bit per pixel, right? So the display here in that window is only 2 bit per pixel, right? What the PPU can see, because it's a tile viewer, right? But these are packed as 1 bit per pixel in the program ROM. So each character, each tile here only takes up 8 bytes instead of the full 16. Yeah. Yeah. So that's why it looks kind of weird and there's overlapping nonsense. Because of that. Actually, can I change the palette for one of these real quick? Edit color 0F. Edit color 0F. Oh, because I edited them wrong. The bug sprite. Nope. The bug palette. Edit color 0F. And this one, edit color with that 27. Huh. I saw that kind of wrong, don't I? Let's make this 3.7, maybe 3.7 like that, and come over here. F1 by 1, so it updates everything, and come over to here. So there's the A. And this one is kind of jank because why? Is that background color? Edit 0F. Just go with it. You get the idea, though, right? Yeah. I probably screwed up a bunch of shit for this, though. Oh my god, does it write that to the background like that? Oh my god, it removes it and then redraws it. Because it's not a sprite, obviously. But, oh god, so it has to like look up that character again every single animation frame. Ah. Tile planar formats, so each plane is about 8 bytes. Yeah. Yep. It is still kind of clever, yeah. They have to expand that into a format that people can actually read while saving space, but it's a pretty obvious way of doing it. Yeah. I've even done it that way. The variable with font stuff that I've done did exactly that. Where I'm only storing 1-bit plane of that, then I'm expanding it before I buffer and draw it to the PPU. Yeah. All right, make over here. Here on that. There's still one warning in there. Durham car. And there are a bunch. Look at all the times it's in there. All right. I might start wrapping up soon. I don't know. D4. What the fuck is D4? I did, yeah, I did a little on here. C, D, 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 D4, DB, D5, D4. Why do I have D2, D2, D3? Oh, because they're both using that same one, isn't it? Go location. What? What? Load 20. Hold up, what? Load A20. Load A, argument A. What the fuck is the load A20 doing there? Huh? Load it, store it, load it, store it. Load it, store it. Timing? But it returns immediately. Back to the script. I wouldn't expect that to be timing stuff. Unless it's like a wait, if it's setting up timing, maybe? Oh god, loop. Oh, I forgot about that loop stuff. Dude, man, how you doing? I'm gonna guess this is leftover from an earlier code or something. I don't know. Byte 606. Where is this used? And this UI is lagging so much. I need to close some stuff. Okay, that's better. Haven't touched that. What is this? Unsure. That's some, like, character ROM setup shit. What the fuck? But I thought we kind of established that the interpreter, at least to some capacity, makes use of macros. So my first assumption would be that this is some kind of case here as well. Yeah. So this looks like it's setting up stuff for the character draw. This is used everywhere too. 604. 605. That's used in a bunch of places too. All right, so we're gonna put a breakpoint there. Oh, it wasn't paused. Okay. It sets some flags. But that RTS goes back into the VM handler, which clobbers everything. Some kind of reason that the macro they use to actually use the value of A. Possibly. All right, so we hit it here. Our code pointer is 6F1D. So we're doing here. Okay. It's just before draw character again. Okay. So it's got to be related to draw character. Okay. So we're going to put a breakpoint on each and every one of these. RWX on that byte. Cool. RWX there and RWX there. Okay. So now we've got a breakpoint on each one of those. I don't care about that. Go to these two guys as well. Okay. Loading it up. How do we get here? Call stack. Execute opcode, sure. 6F24. Okay, draw a ROM character. That stores it in this table. That breakpoint. Next. Oh, this is in a loop. 2. There's a 6-4. Was it the 6? 4? I don't remember which was which. Which corresponded to which argument. There's that. Yeah, so that's some sort of setup for getting that character. How do I draw? Yeah. Yeah, so this is something to do with character setup. I don't know what though. 0xd4. Stack arguments. 3 was it? Yes. All right, let's go back to that. No. Go there. Okay. Argument A goes into byte 606. Byte 0606 equals arg A. Byte. Oh, this way actually. Byte 0604. Arg B and 05 is C. To which bank the character is in? Yeah, anything for screen location to where the character is. 'Cause that could be part of it too. I say it was unknown 0xd4. Before 3. Four and 4. What the fuck? They're all pretty much the same except for that one call up top, which is 2 and 4. Huh. Yeah, I mean, it could be bank. It could absolutely be bank. Because there's more than one bank of those guys. I think, right? At least 2 banks of them. I don't know. Anyway, I've been going for 6 hours. I need to wrap up. I need to wrap up. I'm getting tired. We made some progress though. Could also be screen location if almost all of those are at tile 4 from the top left. They aren't though. That's the thing. Two tiles, like 3-ish. I think, right? Time of viewer. 2, 1, 2, 3, 4. I mean, for one of them, sure. But the others, I don't know. Could be, ooh. Oh, it could be here, actually. Because that's 4, 4. Ooh. So, yeah, okay, so... let me get back over to here. After 5? Oh, wow. That was perfect. They're all in different spots. For whatever the hell reason. Huh. Yeah, the numbers are, yep. And blinking, yep. Yeah, different characters being drawn? Yeah, so this character is always in that spot, and it's always this character. Right? So I'll go to the next one. I'll turn off all of this shit. That's 2. It was 1. I don't think it's redrawing that one, actually. Three. See, that's probably location. That's gotta be. This is like drawing the box for the thing, right? Draw a character. That's the first one. Yes. Yeah, okay, so that... Draw the kanji. Then each of these is drawing the number. Yeah. Okay. This is like set cursor position. Yeah. Yeah, all these are drawing the number. Look at all of them. Because there's a return after every single one of them. Oops. All right, turns to this. Wait for tape. And the loop. God, set up loop. Because that'll flash it, won't it? Fill the box. Start at 4-4. Go to 5-5. Fill it with 0. Fill it. Wow. So yeah, that's that pause. This is animation shit right here. Just wait for tape. I wonder if the tape's actually going during that. Or if there's some sort of timer in the tape in the tape controller that we're taking care of, or they were using. Screens is drawn or something. Relative screen to draw on, maybe. I don't know. How did I forget that this is the stack machine? I don't know. I can't help you there. Yeah. Before I go, let me have a look at this though. What is this guy? Oh, that's the jump absolute. That's probably data. I don't think that's a jump absolute. I think that's actually data. It's fourth, like, yeah. Yeah. Yeah, well, look. Yeah, let's name it like set cursor or some shit, right? Set our location. How about that? No, set cursor location. Make. Oh, because I didn't save. Make. Other instructions, 4 of them. Nice. Yeah. Depends on whether drawing a cursor updates location, the position. It might. Yeah, we'll come back to it. There's still a lot of stuff that I gotta like iron out, right? Like I just started this, and this is very bare bones, you know. Yeah. This just said it might be getting clobbered somehow. Yeah. Yeah. Anyway, I need to get out of here. I need to wrap up. Yeah. So let's see how this is live. I'll go say hi to somebody. Yeah, I'm tired. I need to get prepped for for sleep so I can work in the morning. I don't want to go to work in the morning. I don't want to go to work. Anyone live doing anything? Someone's doing some circuit board stuff. Let's look at this. Mute it for you so you can't hear it. Yeah, we'll go over here. Yeah, so come over there to say hi. I'd really appreciate it. Raid. That one. Yeah, so I'll be back on Friday doing, I don't know, maybe more of this, maybe some more Tetris. I don't know. Unsure. See how I'm feeling. I should be back on Friday, though. Thank you guys for being here. Appreciate it as always. I will see you guys next time. Bye-bye.